Honorable dignitaries, learned delegates, respected teachers and students, a very good morning to one and all. On this beautiful morning, I, Sudeep Kumar Panda, feel privileged to extend to you all a very warm welcome on behalf of the Department of Electronics and Communication Engineering, GIT University, who has clubbed all of us for a brainstorming international conference on smart and sustainable technologies 2021. Research is to see what everybody else has seen and to think what nobody else has thought. It is an occasion like this we get opportunities to test our knowledge and understanding. We look forward to get an exposure about what the best of the brain thinks and about the smart and sustainable technologies of present and future. This conference cover theory, design and application of smart technologies and its application to different interdisciplinary fields for sustainable development. We rarely get this kind of opportunities to learn about different technologies and get new ideas to develop ourselves. So let us grab this opportunity and quench our thirst of knowledge. Dear participants and attendees, allow me to introduce to you all to a scholar who is going to enrich us with his vast knowledge. It is none other than Dr. Dhubaccharan Panda, who is having 7 years of experience of teaching in BTech, MTech, and PG Electronics Science subject. He is a principal investigator of DRDO sponsored project and have 16 international non-trade journal publication and 30 international conferences. He has even guided 2 PhD theses and 8 MTech theses. Currently, 7 students are working for their PhD. He has conducted 3 AICTC sponsored FDP and is awarded as CSIR Senior Researcher Fellowship and has been awarded with DST Young Scientist Award 2006. With immense respect and honor, I warmly welcome Dr. Dhuvacharan Panda to throw some light on the smart and sustainable technologies for future. Sir, please.
Hello, am I audible?
Yes, sir. Yes,
Yes,
sir.
sir.
Oh, thank you very much for the nice introduction. um, um, so, shall I start my presentation?
Yes, sir. You can start, sir.
Is it in full screen now?
Yes, sir. Yes, sir. It's visible, sir.
Yes, sir.
You can start, sir. Dhruva sir? Hello sir?
Yes, yes, yes. Lot connectivity issues are.
Okay sir, okay sir. Right. Hello sir?
Yes. Whether my slide is visible?
Uh, yes sir,
Yes,
it
sir.
is now visible, sir. But sir, some issues is there. Sir, if you are having problems, sir, you can send us the presentation, sir.
Hello? Hello?
Yes, sir. Yes, sir. Good morning, sir.
Hello, sir.
person is concerned, you can see the picture which is a battleship whose dimension is very huge. So when we prototype subjects like this, it takes lots of computational time as well as computational load. So I worked on this topic for, actually I am working on this topic since last 5 years, how to reduce the computational as well as the memory load so that we can rapidly prototype defense objects. So that is what is the objective of this work. Now, this particular topic is a amalgamation of two topics. One is artificial intelligence and the other one is radar cross section. Now, what is a radar cross section? Radar cross section is a physical area. I mean, a virtual area which we compute when we transmit a wave from say transmitter, say in this case we call it as a radar, and that strikes to the object and reflects back. Now, basing upon the emitted wave and received wave, we calculate a kind of virtual area that we call as radar cross section. So what the radar cross section tells us? It tells us, for example, here you see in the red, in the picture, the red colored portions, from here maximum reflection takes place. So from all these edges marked by red color, reflections are taking place. And the other radars deployed, for example, enemy radar, they detect these reflected waves and identify our objects. Now, our motto is, as far as defense application is concerned, we should ensure that reflection should be minimum. Now, there are two kinds of approach. Always from the edges, reflection takes place. So, we have to minimize the reflections from those places or coat it with some kind of material so that it will absorb the incident wave and will not reflect. And also recently a new technique is people are working, that is they coat with the material called meta material, so that the incident wave, instead of it will direct the reflected wave in other direction so that the radars cannot catch. Now, see this pinpoint, this portion, pointed portion, from here maximum reflection is taking place. So when we compare it with a virtual area, it looks like a large area, meaning maximum reflection is taking place. So even if the physical area is very small, the projected area will look like very large. That is what is the that is how this word came, radar cross section. Is it okay? My slide and voice? Hello? Hello?
Yes, sir.
Yes, sir.
Okay,
Yes,
okay.
sir.
Okay. Okay. So, to determine the radar cross section, we take two approaches. One is we position the object and the incident wave on it and rotate the source or rotate the object to determine to know from which area and at which angle reflection is taking place. But see, telling these things is very easy, but when we really go to implement, I mean to determine the radar cross section, it's a multi-crore we have to invest. The labs and the equipments and the environment costs a lot. So before prototyping the defense objects, we need to calculate these things. So there are either I can calculate the radar cross section, or I manufacture the object and determine, I mean, measure the radar cross section. The second approach, I mean, determining, I mean, measuring, building the prototype and measuring the radar cross section takes a huge amount of, I mean, requires huge investment. So before going for prototyping, I need to calculate the radar cross section of the object. And the objects, as you can see, and please recall the battleship from the first slide, they are very huge. And their calculation is also not that simple. Now we have two approaches to calculate the radar cross section before going or before prototyping the objects. Either we can go for high frequency method or full wave method. Of course, we have also analytical methods available with us, but I mean, we can calculate the radar cross section with analytical formula, but that is confined to simple objects like a sphere or cylinder, regular shaped bodies. For regular shaped bodies, we can calculate, but for real object, it's very difficult. I mean, we cannot use the analytical approaches. So we are now left with two approaches. One approach is the high frequency method, and another one is the full wave method. Now, what happens in high frequency method? We assume the waves as a rays, as if the rays are incident on the object, and the object reflects back. So physical optics formulas we can use to calculate the radar cross section, but then it has a problem. If the object orientation changes, then the same radar cross section value will not be valid for that orientation and angle. I mean, it is angle and orientation dependent, but it's very fast. Fast in the sense, say within 10 minutes you can calculate to the high radar cross section, but it is not accurate. And when it comes to defense application, we cannot compromise with that. So we are left with the method, full wave method. Now, what is the basic principle of full wave method? Is, the electromagnetic wave interaction, wave and object interaction, it is governed by Maxwell's equations. So we discretize the wave equation and implement in a computer and calculate the radar. Any other parameter, all interaction can be calculated using Maxwell's discretization method. So there are three approaches. One is the finite difference method, another one is the finite element method, another one is method of moments. Using all these methods, we can calculate. But these are depending upon the objects. See, if you ask me how the industry calculates, they deploy supercomputers to calculate radar cross section, and the supercomputers take weeks and months to calculate one iteration. So when you see that the radar cross section from this area is large, then we go for tweaking the shape, changing the shape, and again recalculate. So that means it takes years altogether to come out with a good prototype. Now suppose we want rapid production, then this calculation has to be done very fast. So this is the problem. The problem, I say, is we need a faster method to calculate radar cross section, and we proposed our idea. That's what I'm going to talk in next few slides. So our idea is to use finite difference time domain method to calculate radar cross section. In briefly, I will tell what is the finite difference time domain method. Finite difference time domain method uses the Maxwell's these two time dependent equations. When the transmitter sends the electromagnetic wave and it interacts, and after interaction it passes, it goes to infinity. So this portion is called the computational domain. The computational domain is now divided into large cells like this, cubical cells. These cubical cells are called E cells. E cells means E first proposed this method of computation. As you can see, the E cells contains electric fields and magnetic fields. So we calculate electric fields and the magnetic fields at each point on the E cell using the Maxwell equation. So when we discretize the Maxwell's equation, we get 6 equations. Then they are in this fashion. I'm sorry, this equation is a little bit blurred. So basically, when we calculate electric field, it uses the surrounding magnetic fields. Similarly, when we calculate magnetic field, it uses the surrounding electric fields as well as the material parameter. The material parameters are conductivity, permeability, and permittivity. So this is the algorithm. We initialize all material parameter and electric field values. Then we excite with a plane wave or depend the source type depending upon the problem. Then for each cell we update electric field and magnetic field. Then we apply boundary condition. Boundary condition meaning the computation domain is infinite in size. So somewhere we terminate it. So it needs initial care to calculate the fields at the boundaries. So this loop, for example, for 10,000 iterations means the wave comes, interacts, and goes away. This takes some time. So depending upon that time, we fix the number of iterations. I mean, how many times we have to update the field values. So that for some cycles, 6,000 cycles, we have to go on doing this. So initially we start at a point, we send the source, at that point the field values exist, at the other points the field values are 0. Then again we go for next cycle, using these fields the surrounding fields are calculated, using these surrounding fields and the other fields are calculated. As we go on doing this, the field values will be updated at each point. So for 10,000 iterations, at each point on the cells, we have to calculate electric field and magnetic field. Now you can imagine, depending upon the size of the object, how many cells will be there, how many fields will be there, and for how many times we have to update. So all these cascades into huge amount of computational load as well as time. Now, how do we calculate the radar cross section using FDTD? We place the scatterer or the target at a place, and it is surrounded by the computational domain. Then the field is incident and it is scattered back, and the FDTD updates the field. And to calculate radar cross section, we can imagine a sphere, and on the sphere we need to know the electric fields and the magnetic fields at the far field. Far field in the sense at a certain distance, not greater than 2d square by lambda from the scatterer. At those points we need electric field and magnetic field. That means the sphere at the far field will be very large. So even it will take an infinite amount of time. So after some years, algorithm came. That algorithm is called the near field to far field transformer. A transformer which needs only the field values in the near field, and using that it can tell us what could be what will be the far field values. I mean, on the imaginary sphere at the far field distance. In order to do that, the transformer will take the surface currents. The near field to far field transformation means or device or the method says we enclose the scattered with a small cube in the near field, very near to the object, and on that point we update the electric fields or calculate the electric fields and magnetic fields. Using both the electric fields and magnetic fields, we can calculate surface currents on that, and using the transformer uses those surface currents to calculate the far fields. Okay, that is what is the algorithm which can give us the far field values using this approach. So this is how almost all full wave solvers they calculate the radar cross section. Next, we will use neural network to this to shorten the simulation time. Then how do we do that? If we closely observe this algorithm, it meets the electric field and magnetic field on the enclosure which is in the near field region. Now, as we iterate the FDTD algorithm for say 10,000 iterations, then at a particular point we can imagine at that point the field evolves, means it starting from zero and gradually it changes its value according to the source and interaction type, and gradually it becomes zero. So it is basically a time series. It becomes a time series. Now when it becomes a time series, so we can with an idea, let's say for 10,000 iterations I know the field values. For rest of the 9,000 iterations I predict the time series instead of using the FDTD full wave algorithm. And this is not a new idea. People have, I think it is around 1950s, the time series predictors have been used with FDTD to shorten the simulation time. And then we came with a nice interesting idea. Now before telling that, I will tell briefly about neural network. Generally this network is called a feed forward neural network. It takes input and it gives us output. Now what is the input? Suppose there is a phenomenon, we have inputs and output data, but how the output and inputs are related we don't know. Then we train the neural network once with the data set. Once it is trained with the data set, it knows the mapping between input and output. Then for unknown values it can predict. That is what is the feed forward neural network, working principle is. So in the same way we can also extend it to a time series predictor, meaning we will train it with 1000 iterations. For say for first iteration this is the input, for second iteration this will be output. The output will be this. Then for second iteration the time value will be this. For the third iteration the value will be this. In this way it will be trained. Then we say the version of the neural network is a recurrent neural network, and during that process it will use delays, some kind of time delays to correlate between the time series. So a time series neural network will when after training, when you ask it with what will be the next time step, what will the field values at the next time step, that it can predict. Then here comes the power of neural network, mean how many steps it can predict. So there are long time predictors, short time predictors are there. We zeroed on this particular neural network, that is called an RX neural network. Apart from the regular time series, it also takes an external or another time series. That means one time series is predicted with reference to another time series. This this is our idea. What about using this as a field predictor? Now what will be, for example, at a room we are trying to predict the pressure time series and temperature time series. Suppose we are trying to predict the pressure time series with reference to time temperature time series in that room. So here we are predicting one time series with reference to another time series. that idea we thought of, and we experimented with the input time series because we know what will be the input excitation, that we know. The input we took as the reference time series, and at the time the field set points are our required time series. This concept we incorporated with the Narex neural network to predict the field values at the observation point, and it nicely worked. Now, before applying that, we also asked the hypothetical question: can we predict the electromagnetic scattered time series using neural network? Then we use statistical techniques to assess whether the fields are predictable or not. If they are predictable, then how many delay elements will be used? See, the neural network is very powerful, but it has its own power problem. The problem is you cannot determine, I mean, we don't have any thumb rule to determine the network dimension. Then another question is, we always can predict deterministic time series, but if it's random or white noise, then we will not be able to predict. So these statistical techniques, next slide I will show. We took a sphere, we took a cube, and we took a sphere cube. See, objects like this are generated using FDTD. As I said, we have worked for 5 years on this problem. So all these are problems. The statistical techniques are throw many challenges to us. The network throw challenges to us, and the computation. Then the other point is, see, on this there are many fields on this virtual enclosure. So that means we need many networks. So many networks has to be trained. All these challenges we took around 5 years. Now this diagram shows that the autocorrelation is more towards this point. That means 5 to 6 delay elements are sufficient. 5 to 6 delay elements are sufficient to predict the time series. That is what this plot says. And this plot, here we calculated the mutual information. Here we can see mutual information is more for 6 to 7 number of delays. So the correlation is very less when delay elements are more. So that means we came to know that 6 to 7 delay elements are sufficient to pick the time series. Now, empowered with this, these facts, we design accordingly our Narex neural networks. So this is what is the algorithm. This is our core FDTD algorithm. For 10,000 iterations, it will generate the data, and it will train the Narex neural network, and the network will predict for rest 9,000 iterations. 1 minute. Hello? Asa? Fast. For rest of the iterations, the network predicts, and using these data, we calculated the RCS. We also communicated all these results to journals, and we got 3 publications and many IEEE International Conference publications. We tested for all these objects. For example, this is a cylinder hemisphere, and this is a dielectric plate, and this is the data almond, NASA almond. This particular object is NASA almond. This is a cone sphere. This is F-16 fighter plane prototype. We generated these targets in FDTD. You can imagine the amount of time we could have spent on this. And people always ask what is your result for the NASA almond. The NASA almond is a very interesting object because it coincides, or its shape is very similar to our fighter airplanes. So that is why people always ask what is the result for NASA almond. Now we added that to all these objects. Actually, I will show one or two objects only. So we took a sphere as our target, and we calculated the RCS, and see here for different radius we have tested, and this is the time taken. Time taken by pure FDTD and neural network incorporated FDTD. It's natural. The FDTD time is very less. The FDTD time is very less, and FDTD neural network time is very large because, as I said, we need to calculate the field values at multiple points. But as the scene increases, as you can see, the FDTD neural network given FDTD computational time outbids after a certain point to FDTD time. That is what is the conclusion we got. Now this is the computed radar cross section. Computer radar cross section, you can see we tested with many commercial standards, and our results are pretty close with the computed values. I mean, with the standard software, the error is very less. See, the radar cross section data is also a private property. Person A will not tell person B what is the radar cross section they have measured. So it is like a state secret. We cannot generally the DRDOs and then CSIR labs, they measure the RCS for different targets, but they keep it themselves. It's like a secret. They will not share you. And for the dielectric cone also we have tested, and you can see the results are pretty close. And then finally, we established the computational complexity of FDTD algorithm and FDTD NRX algorithm. As you can see in the this picture shows that also the table I have shown, as the number of cell increases, initially the FDTD time is very less. Initially FDTD time is very less. But after some time, the FDTD NRX time is less compared to FDTD time. So that is where the object dimension naturally, for smaller objects, the FDTD time will be very less. We also developed computational complexity algorithm proof for the advantage of our approach. I think I'm at the end of the presentation. Hello? Hello?
Hello, sir.
Yes, I'm done.
Hello, sir. Can you hear me, sir?
Any questions? Yes. Any questions from audience?
Hello, sir.
Yes, any questions?
Sir,
Any questions?
Hello.
Yes.
Are there any questions from the audiences?
Yes.
Hello.
Hello, sir.
Yes, yes.
Sir, you have given a nice presentation, sir. Sir, I have one question, sir. Sir, in detecting
Hmm.
the target, sir, which kind of signals can be used, sir?
Plain web, plain web.
Hello, sir.
Plain web, we use plain web.
Your voice is not clear, sir.
Plain web.
Hello, sir.
Yes, we use plain web.
Just give us a minute, sir. We are facing some issue.
To
Just give us a minute.
in target detection, sir, what kind of pulses can be used, sir?
Gus,
Okay, sir.
yes, any other questions?
Sir, can you, sir, turn on your camera, sir, so that we can take a screenshot, sir? Yes, sir. Thank you, sir.
Thank you, sir. Thank you very much for sharing your profound knowledge on application of different types of neural networks and its power to modify radar cross-section. Thanks.
I'm leaving them.
Moving forward, the next honorable Second time. Moving forward, the next honorable dignity to honor us with his presence is Dr. Srukanta K. Tripathi, who holds a PhD degree in physics from Berhampur University. He has been teaching physics in the Department of Physics, Berhampur University, since January 2016. His current research interests include nanophotonics, including quantum dot sensors, solar cells, and optic fiber quantum dot hybrids. He has guided 6 doctoral students and has about 40 publications to his credit. He has collaborated for research with University of Electrocommunication Japan, Brunel University London, Institute of Atomic and Molecular Science and Center for Condensed Matter Science, and TU Taiwan. He has authored one book on material science and engineering and edited another book, Functional Materials, with Professor S.M. Bose of Drexel University, USA. He has completed one DST funded project. He is a life member of Photonic Society of India, Optical Society of India, Indian Society of Technical Education, Orissa, Physical Society, and a member of IEEE Photonics Society. He is a reviewer of IEEE Photonic Journal, Journal of Applied Physics, Journal of Modern Physics, and Chinese Optical Letter and Optical Fiber Technology. With immense respect and honor, I warmly welcome Dr. Sukanta K. Tripathi to throw some light on the smart and sustainable technologies for future. Sir, please.
Okay, can you hear me?
Yes, sir. Yes, sir. Audible, sir.
Audible.
Good
Okay.
morning.
Okay, morning. I think you can see these slides, right?
Yes, sir.
Okay. Good morning to all of you. So the presentation which we'll make today is something related to microscopy. As you can see the title of my talk, this is about digital holographic microscopy for a detection of a blood glucose level. In fact, I will talk about the basic principle of holography microscopy, in fact, digital holography microscopy. And also I will give you a feeling how you have used this digital holography microscopy for the detection of blood glucose level. Before starting my talk, let me tell something about my Center of Excellence. In fact, we have a Center of Excellence at Berhampur University, and the Center of Excellence is dedicated for the development of low-cost sensors. And we are trying to develop low-cost sensor basically in 3 different areas. As you can see here, the first area where you can use the sensor is in detection of toxic gas, which is related to the environment. The second area is the use of optical sensors for the biomedical parameters. And the third one is in food security to detect heavy metals in your food contents, waters, and so on. In fact, we have developed some prototypes for these sensors. In fact, this talk is something related to the second area where you have developed a sensor based on this your holography microscopy. And we have also developed another sensor to detect heavy metal ions like mercury. And both the sensors are based on some optical principle. The sensor which I will talk today is based on the holography microscopy, in fact, digital holography microscopy. Whereas the second prototype which we have developed is something related to, the imaging. In fact, to image in terms of, or to calibrate in terms of RGB of a digital image. So with this brief idea about the Center of Excellence, let me go to my talk. And as you can see, the plan of talk is something like this. I will take some time to explain about this photography and holography, assuming that the audience may not be aware of this holography. So I will take some time to explain about this photography and holography. In fact, I will distinguish between these two terms, this photography and holography. And then we will see the basic principle of holography. In fact, the basic principle of holography is based on interference of light, which all of you might have studied, maybe your intermediate classes. And the holographic recording and reconstruction process, the basic recording and reconstructing process in any holography technology, we will mention. And we will concentrate more about this digital holography next, because the microscope which you have developed is based on digital holography. And therefore, we will take more time to discuss about this digital holography. And finally, we will see how we have developed this low-cost holographic microscope. In fact, this microscope we have developed with the active support from this Bhabha Atomic Research Center. You might be knowing that there is a Bhabha Atomic Research Center, particularly working in photonics in Visakhapatnam. So we have collaborated with them, with Dr. Rao, Dibakar Rao, which is the head of this photonics group. And with their collaboration, we have developed this low-cost holography microscope. And we have tried to use this holography microscope to measure this HbA1c. In fact, this HbA1c is something to detect or to do with this blood glucose level. And we'll see what is that HbA1c and how we have detected this HbA1c based on this digital holography microscopy. And of course, finally, we will give some concluding remarks in the sense we will try to explain is there any method by which you can improve this detection of HbA1c in future or not. Now to start with the difference between this photography and holography. In fact, this photography is a well-established technology. All of you might have aware of this. What you are basically doing in this photography is recording this distribution of light intensity. And in fact, when you are taking a photograph, the ordinary photograph, basically we are recording this amplitude on a recording medium. And therefore, we are losing this phase information, because you might be knowing that if you have a light signal, this light signal consists of two parts. One is the amplitude or intensity, and another is phase. So in an ordinary photograph, what essentially you are doing is you are recording this reflected light intensity from a three-dimensional object, and you are leaving the phase. So you are not able to record the phase in case of regular photography. And therefore, we are not able to get the three-dimensional scene of this object, because this phase is not recorded. Because if you record phase, you will get the depth information. So the depth information is only available if you can record this phase. So because you are not recording this phase in case of regular photography, you are losing this three-dimensional scene of this object. And if you try to record this three-dimensional scene of an object, then you have to record this phase information. So this holography is a technique where you are recording phase as well as the intensity. So both intensity and phase are recorded in case of holography. In fact, holography is due to this two term you can see here. This is in fact a Greek word. Holo means the whole and graphy means the writing. That means if you are writing the whole object in the sense three-dimensional object, then this is called as this holography. And in holography, what essentially you will do is you will record two beams. In fact, in photography, this is not the case. In photography, what you are doing is you are putting this light signal to an object, and the light signal is reflected from the object and is recorded on a recording medium, a photographic plate. But in contrary to this, in a holography, you have to record this signal from this or reflected signal from the object as well as another reference signal, which we'll see it later. So therefore, this photography is not a interferometry where two beams are superposed, whereas holography is a technique where essentially you are using a technique which is called as the interferometry. So interferometry technique is not new. In fact, you might have studied in your earlier plus 2 classes or intermediate classes. This is the famous Young's double slit experiment for this interference. And as you can see here, if I want to superpose two coherent beams, then essentially what you could do is you have to produce these two signal sources from a single source. So this is the single source from which these two sources are produced, and therefore these two sources will behave as two coherent sources. And if you will try to superpose these two coherent sources, then what you will get in this superposing plane is some dark and bright fringes, which are called as the interference fringes. And these interference fringes will look like something this. You have some bright patches, then dark patches, dark page, bright page, something like this. And this is called as the interference pattern. So the interference pattern which you see in this diagram is basically due to the interference of two coherent signals. And these two coherent signal in this case are derived from a single source. And this expression in fact gives the relation how this intensity on the superposing plane will vary with the different parameters, right? So based on this, in fact, you can plot this graph, the variation of intensity. So this is to just recollect the ideas which you have studied in your plus 2 classes, that if you want an interference pattern, then you have to superpose two coherent signals. And these two coherent signals can be produced if you can get these two sources from a single source. As you can see here in this experiment, Young's double slit experiment, you have some monochromatic source here, and this monochromatic source will be illuminated by these two different slits, and therefore this slit will behave as one source and this slit will behave as another source, and these two slits will behave as two coherent sources. So when this light from two coherent sources will superpose on this plane, then this will produce what is called the interference pattern. So with this basic ideas of interference, let us try to understand what is this principle of holography. Now, in this slide, as you can see, I have represented this process of holography with these two different processes. The first process, which is called as the recording, and the second process is called as the reconstruction. Now, what essentially you are doing in recording is something similar to this interference. So in this first process, which is called as recording, we are using two coherent beams. This is one coherent beam and this is another coherent beam. And these two coherent beams are allowed to superpose on a superposing plane, maybe a photographic plane or the photographic medium. So when these two signals, coherent signals, will interfere, then what will be formed here is called as the hologram. Of course, you have to take this and you have to process this, and then you will get this hologram. Now, to mention these two beams or to name these two beams, this beam, in fact, is not something similar to this interference pattern. In fact, this beam is obtained after reflection from this object. As we have explained earlier, that if you want to take a photograph, then you have to incident light to an object and then you have to take the reflected beam. This is what you are doing in an ordinary photograph. But here, in addition to this reflected beam from the object, we have to use another beam which is called as the reference beam, and therefore this beam which is called the reference beam is to be superposed with the beam which is reflected from the object, and therefore this beam is called as the object beam, right? And as you can see, this reference beam and object beam are superposed on this recording medium. So this recording medium, if you talk in terms of material, is something like dichromatic gelatin, DCG, okay? And As you can see here, I have represented this reference beam by some equation, and here also object beam some other equation. Now, this is obviously the amplitude of this reference beam, and this is something related to the phase of this reference beam. And similar is the case here. This is the amplitude of the object beam, and this is the phase of this object beam. Now, what will happen when able to interfere or superpose these two beams is this. Now, here we have superposed this object beam and reference beam, and when you will do that with some little mathematics, you can show that the intensity which will be recorded in this photographic plate is something like this. And this first term which is presented here is something related to this intensity. The second term is again related to the intensity. This is the intensity due to this object beam. This is the intensity due to the reference beam. And these are the two cross terms. And as you know, this will be real because this is O star. So therefore, this will be a real term. This will be a real term. So therefore, this intensity which you are getting here is something real. Whereas here, this O R star and O star R is definitely not real. This is a complex quantity. And in fact, this is the term where this phase is recorded. So here, this is in fact related to intensity. These two first terms are related to intensity, whereas this and these terms are related to phase. So therefore, what you are recording in case of holography is intensity as well as phase. So this is your intensity. First two terms will represent intensity, whereas the third and fourth term will represent the phase. Now, this is about the recording process. Now, what will happen in case of your reconstruction? Once you have recorded this, then you take this, developed photographic film or medium. So this is the developed photographic medium in the sense, suppose you are taking an analog hologram, then you have to take this inside a dark room and you have to process this. This is something similar to the processing of a photographic film in ordinary photography. If you might have observed, maybe 10 to 15 years back, you are taking some analog photograph where a film is to be introduced into the camera, which is red in color. Now, once this film is exposed, then what will happen is you have to take to this dark room and you have to process this, film so that you will get what is called as a negative. Similarly, what you are doing here is you have to take this photographic medium after this interference pattern is recorded to a dark room, and then you have to process it. And when you will process, then you will say that this is the developed hologram. Now, once you have a developed hologram, then you can get back this three-dimensional object if you can sign the same reference beam which you have used for recording. For example, here I have used this reference beam for recording. Then if you will put or sign this same reference beam, then you will get back the same object which you have recorded in this hologram. Now, just to have some mathematics, see, this is your R, okay, and what you have recorded here is this. This is what is recorded here. So when you will put this beam, what you will get here is something R dot T. So R is this beam and T is what you have recorded here. So therefore, what you are getting essentially is mathematically this term multiplied by this R, and R is nothing but this R prime e to the power I psi. So if you will multiply that, what you will get is something like this. So beta, of course, is a constant, which is a characteristic property of this medium. So therefore, when you will put this signal onto this recorded and developed hologram, what you will get is the intensity term. This is in fact your phase term. So this is the phase information which you are getting, and this phase information in fact will give you the three-dimensional or the depth of this object, so that you can sense the three-dimensional sensation of the object. So this is actually the reconstruction of this original object. Now, what I'm interested here is not a hologram which we are recording using a laser beam, and also you are using some real holographic medium like for dichromatic gelatin. So what you are using now is what is called as a digital holography. Now, what is this digital holography? Now, as I have said here, uh, if you are recording this on a real photographic plate, then this is called as the analog hologram. But equivalently, I can also record this on by using a digital camera. That means I can also digitally record the interference pattern. So if you will record this interference pattern digitally, then this is called as the digital hologram. Right? Now, in digital hologram, you will use two laser beams, real laser beams, and record not on a real photographic plate, but on a by using your digital camera. So therefore, this will form what is called the digital hologram. And reconstruction also you can realize not by putting a real laser beam or reference beam, but you can use some computer programming and of course based on basic mathematics, so that you can reconstruct this object. So if you will reconstruct the object not by putting a reference beam, real reference beam, onto a processed or developed holographic film, then this is called as digital reconstruction. This process we have differentiated in this slide. So this is actually the holograph reconstruction, and this is the holograph generation. Now, as I have represented here, I can generate or record this hologram by classical method. That means by using optics, and also I can generate this hologram by using computers. Now, when you will record this hologram, when you will record this holograph by using computers, then this is called as computer generated holograms. That means in this case, you do not use any real laser beams as by using classical method. In classical method, you will use two real laser beams, and you will interfere them. But if you are not using really two laser beams, then this is called as the computer generated hologram. So you can write some programs, and which will in fact this will represent this object beam, reference beam, then superpose them, use some basic mathematics, and you will get this computer generated hologram. Similarly, the reconstruction process also is based on classical method. That means by illuminating the hologram by a coherent plane wave, and also you can do this by a computer. That means by using some digital hologram. So what I will now explain, or what we have done, is a digitally recorded hologram. In the sense, we have used the classical method for recording. That means you have used two real laser beams. You have recorded really two laser beams on this superposing plane, but we have not used any real recording medium, but we have captured this image by using a digital camera. So therefore, the capture of this interference pattern is not by using any holographic plate, but by using a digital camera. And the reconstruction which you have made is again not by using some coherent plane waves, but by using some algorithm, and therefore ours is a digital hologram. That means we have reconstructed this by using a digital, or but by digital method. So this is the basic difference between the analog hologram and digital hologram. So to just clarify what we have done, you can say that we have used two real laser beams, but not recorded this interference pattern on a real recording medium like DCG, but you have captured this by using a digital camera. Now, once you have recorded this by using a digital camera, then you take this as the input to the computer program, and the computer program will in fact reconstruct this three-dimensional image, and therefore this is a digitally recorded hologram, and reconstruction is also digital. Now, just to give some basic mathematical background of this recording and reconstruction, as you can see here, this is the intensity which you will get when you will record a object beam and reference beam. Now, if you see here, when you will record this object beam and reference beam, and object beam, as I have mentioned, is represented by phase and amplitude. Similarly, reference beam is represented by phase and amplitude. And this essentially is the intensity of the object beam. This is the intensity of the reference beam, and this is related to phase. This is also related to phase. Now, we will not go into detail of that. In fact, there are different ways by which you can record this hologram, maybe making some angle between this reference beam and the object beam, which is our case, and this is actually called the off-axis hologram. So there is some angle between this reference beam and on the object beam. Okay, so this intensity which you have recorded contains both the intensity information here and the phase information here. So these three terms, in fact, will give you three different distribution of intensity. And if you want to have a feeling how this, in fact, the pattern will change with the object. For example, if you have an interference pattern, which I have shown in previous slides, this will consist of a number of dark and bright fringes. Now, suppose I will put a sphere, or I will take a sphere as the object. Then what will happen in the hologram? The straight fringes will be changed to some pattern like this. You can see here. So this is not just like a straight pattern. Here, this pattern changes in accordance with the shape of this object. Because the shape of this object, this pattern is something curved like this. So this is the, the signature of the object which is present in one of this beam, that is the object beam. So the fringe carving is the capture of the phase. So if you are not recording phase, then definitely you will not get the curvature. So because you are recording this phase, the curvature is also visible in the recording pattern. So if you want to just take a, image of your, sphere in ordinary photography, definitely you are not going to see this curvature. You will simply get a two-dimensional sphere, and the curvature information will be lost. Because you are recording this phase in addition to this intensity, therefore this curvature effect is clearly visible here. So this is the beauty of, in fact, a hologram. Now, once you have recorded this hologram, the next thing what you are doing is you are reconstructing this hologram by using what is called as digital method. Digital in this sense, you have to use some mathematics to get back this object. Now, how will you get back this object is something like this. Now you have this intensity, because when you will record, you will get this intensity here. Now, once you get this intensity, or when you have recorded the intensity, and if you want to visualize these three different terms, in fact, these are the three different terms. As you can see, this is 1, and this is 2, and this is 3, because this 2 will give you the intensity term. So what you have to do is to reconstruct these objects, first you have to take this to the Fourier plane. So you have to make a Fourier transform of this intensity. Now, when you will make a Fourier transform of this intensity, then what you will get is this. This is the Fourier transform of the intensity. And as you can see here, this will contain three different terms. And the first one is the DC term, that is the intensity term. And this is the phase term of the first order. And this is the phase term of this minus order. That is, this is +1 order phase, and this is minus 1 order phase. So that means this is the hologram which you have recorded. That is the hologram which is recorded digitally. And once you will make a Fourier transform of this, then you will mathematically get this, and the visualization is this. The visualization of this is something like this. This in fact correspond to this intensity, this correspond to this minus 1 intensity, or this correspond to this plus 1 order. So this is the minus 1 order, this is the plus 1 order, this is the intensity which you will get at the center. So the DC intensity term will be at the center, which will be surrounded by plus 1 order and minus 1 order. Now, as I said, there is no phase information here. Phase information is only here or here. So therefore, what you have to do next is you have to eliminate, or you have to crop this DC term and either this minus 1 order or plus 1 order. So let us say I will eliminate this and this, so that you will get only first a minus 1 order. That means only you will take this term where this phase information is there. Equivalently, you can also eliminate this, and you can take this plus 1 order. So either I can take this term or this term to get the information of phase of this object. So what next is done is we have to crop this first order and the DC term, so that you will get only this. Okay. And once you will get this minus 1, that means in this plane you will get only one intensity, which will correspond to this minus 1. Then you take this. So definitely this will be not in the center of this image plane, and therefore you have to take this to the center of this image plane, and you take this to the center of the image plane. You will to crop this DC term and the plus 1 order term. DC term and plus 1 order term, and you only retain this minus 1 order term, and then take this minus 1 order term to the center. Now, once you will take this minus 1 order term to center, then this will look like this. As I said, this is in the Fourier plane. So this is not the real plane. So if you want to get back this object again in the real plane, you have to take an inverse Fourier transform of that. And if you take the inverse Fourier transform of this, then you will get this image. In fact, this is the phase image of this object. So you are getting this phase image of this object, and why I am getting this phase image of the object, I will mention in the next slides. So what I'm trying to explain you is, by using this holography, you can get the phase information of this object. So in fact, I have obtained here the phase information of this sphere. So this is in fact the phase information of the sphere, and I can calculate what are the phases at the different points in the image plane. So this is how the phase is recorded and phase is reconstructed. Now what you have done is something like this. This is the schematic diagram of the digital holograph microscope, which you have developed with the collaboration of Visakhapatnam. In fact, they have helped us for designing, and also they have given some microscope, but we have improved that microscope in different directions, and finally we have used this for the detection of HB1C. So the basic principle of recording, which I have explained, is now utilized in this schematic diagram. As you can see, this is a laser diode, and this laser diode emits this light here, and this light is divided into two parts. As I said, if you want two coherent beams or two coherent sources, then you have to derive this from a single source. So this is the single source from which you have derived two light signals. Of course, this is laser. So we have derived two lasers or two coherent beams, and this coherent beam or this laser signal is allowed to pass through this object. In fact, this is the sample. So this is the object of which you want to phase information, or you want to record phase information. So one signal is allowed to pass through this object, and it is going like this, and another signal is going directly to this. So then this signal superposed with this signal. So definitely this is the object signal, and this is the reference signal. So this object signal and the reference signal, they superpose and they produce some interference pattern, and this interference pattern is recorded with a camera, okay, digital camera, okay, or you can use some smartphone on the camera of the smartphone to record this interference pattern, and this will give you a digitally recorded hologram, which actually we have used and try to find the phase information. So the different components which you have used, like this is in fact a beam splitter which will split the beam something like this, okay, into two parts, okay. This is in fact a coupler which will divide the signal into two parts. This is one signal, and one signal goes like this, another signal goes like this. And in fact you might have studied about this couplers, 1x2. In fact, this is a 1x2 coupler, and the amount of intensity which will be divided is based on your requirement. For example, because this signal is to transmit through a sample, therefore this intensity should be something more than this. Therefore we have used some 75 to 25 coupler. That means 75% of light will come over here, and the remaining 25% will go here, because the 75% of light is to be transmitted through a glass slide where we put some sample, and this is going directly there. Therefore there is no loss in intensity here, whereas here there should be some loss of intensity. And looking this into picture, we have increased this intensity here, we have made this intensity something less, so that you can get some good quality, interference pattern. So this schematic diagram which I have explained here is realized in this real laboratory setup. If you see this diagram, in fact this is the digital holograph microscope which we have developed with this collaboration with this Bhark Visakhapatnam. In fact this is the laser source. Laser source is here, and this is operated with this driver, in fact. So the laser source is here. This is in fact a 630 nanometer laser, 3 milliwatt, okay. So this is in fact an optical fiber. So we took this light from this laser, and this is in fact this is a 1x2 coupler. That means the light from this laser is introduced somewhere here, okay, and then it is not clear, of course. So this is the input from this laser light is coming through this optical fiber like this, like this, like this, like this, and here. And then from this, one is going through this, and another is coming here. This white one which you are seeing is going somewhere here. You can see some yellow wire is there, a yellow fiber is there, in fact. So here this is a beam splitter, 1x2 coupler, okay. This 1x2 coupler will split this light into two parts, and this part is in fact 75%, because this will go through this, and it will, because there is a slide here, so this will go like this, and then it will enter through this slide and will go here, whereas the other fiber is going here and is coming directly here. So this is actually the arm where the light is 25%. The intensity is light is 25%. So this is 75 and this is 25. So this light will go enter into this, okay, and this light will go directly here. So the interference pattern will take place in this plane, and you can see a mobile phone. In fact, this is the mobile phone, and there is a camera of this mobile phone, and the camera of this mobile phone is used to record this, interference pattern. Now, once you have this interference pattern, then this interference pattern which you have captured here is taken to this laptop, where you wrote some program to reconstruct this, digitally recorded hologram. In fact, we have used some Python program to reconstruct this, digitally recorded hologram. So this is in fact the basic, principle, and how you have implemented this principle in this digitally holography microscopy. Now coming to this application of this digital holography microscopy to measure the HbA1c level in the blood serum, I will just tell you the importance of this measurement of HbA1c in your blood serum. You know, this diabetic is a common problem nowadays, and this will be more serious maybe in the coming next 10 years. Now, when the blood glucose level increases from a critical value, then it is said that the patient is diabetic. Okay, or this is a diabetic patient. Now, usually for the diabetic person, uh, we measure this blood glucose level, and there are different types of tests for the measurement of blood glucose level. For example, there is fasting blood glucose level, where you have to test the glucose level in the morning when you are not taking any food. So with empty stomach, you have to measure this glucose level, okay, of your blood serum. And then after taking food, you have to wait for another 2 hours, and then again you have to measure this glucose level. Then this is called as the glucose level after 2 hours. 2 hours. And generally it is said that if your glucose level fasting is less than 110, something like that, then this is okay. Similarly, if your glucose level is less than 150 or 60, something like that, after 2 hours, then it is okay. Okay. So this is the standard, in fact, for this measurement of your blood glucose level in blood serum. Now, then when you are measuring this fasting blood glucose, or you are measuring this glucose level after 2 hours, then this will give you the glucose level at that instant of time when this blood has been taken from your body. This will not give you the glucose level maybe at before time, right? Now, for example, is there any method by which you can measure this glucose level, or how your glucose level varies in the last 2 to 3 months? So can you just track the variation of glucose level during the last 3 months? Then there is a method, and the method is by measuring the HbA1c test level of the blood. HbA1c is something related to hemoglobin A1c. So what basically this HbA1c will give you? This will give you the glucose level of your blood in the last 3 months. And currently, there is an equipment which is used for the measurement of blood HbA1c, and this is called the HPLC, high performance liquid chromatography. Okay, and the cost of this HPLC is around 5 to 6. And if you will measure this HbA1c using this HPLC, this reading will be in percentage. For example, if your HbA1c level is less than 6.5 percentage, then you are okay. If it is more than 6.5 percentage, then there is some problem. You have to take medicine. Okay, this is the standard procedure for measuring HbA1c. Now, as I said, the cost of HbA1c is 5 to 6 lakhs. So therefore, ordinary pathology center cannot afford to have this HPLC. So in this sense, this equipment we have used to measure this HbA1c level. And if you'll ask me what is the total cost of this setup, excluding this laptop, just let us just take out this cost of this laptop, because finally you are trying to do everything in this mobile phone. So if you will process all these things in a mobile phone, including this mobile phone, this will come around 20 to 25,000. That means the whole cost of this equipment or setup will be something 20 to 25,000. You are validating this by using this laptop, but finally we will implement everything in this mobile phone. We will not take this image to this laptop. So therefore, the cost of the equipment will be drastically reduced, and a common pathology center can afford to use this facility. This is the main aim of this design of this low cost sensors for healthcare. Now, having said that, let me just give you a background of what you have done. In fact, this RBC, the red blood cell, okay, there are different features of this RBC, and you can see this different features. F1 to F14, there are 14 different features of RBC, and you can measure this 14 different features for different disease identification, and we will not go into detail of that, but I will mention few of these features. For example, F4, F7 and F13. For example, F4 is related to the average phase value, and F9 is related to elongation, and F12 is related to perimeter, and F14 is related to again this elongation. So these are some of the parameters of importance, because by measuring the parameters you can identify many biological parameters. And in our case, we have used this F4, that is the average phase value of this RBC, to detect this HbA1c level. So F4, as you can see here, is the average phase value, and this is the average phase value for pixels within a single RBC. That means you have to take the single RBC image, and then you have to calculate this phase of the single RBC, and then you have to measure this phase. Now it is found that the average phase value of this RBC is something to do with the glucose level, and as you know, RBC can live for minimum 3 months. So that means if you measure this sugar level in RBC, this will give you an idea about the sugar level since last 3 months. So now what you have done is something like this. We have, of course, when you will do an experiment something similar to this, then there will be some ethical issues. So you have to take care of this, and therefore we have contacted this MKCG Medical College, and we have contacted some professor of pathology, and this Professor Atanu Bal, and he is actually helping us to give these samples, samples for this blood, actually blood samples, okay. And these blood samples we got from this medical college. Then we take the help of the Department of Zoology to extract this RBC from this blood sample. And once this RBC sample we received from the Department of Zoology, then we started our imaging principle. Okay, so this is in short, because the time is already over, so just I will take another 4 to 5 minutes to wind up. So this is in short what we have done. We wrote some program in Python to implement this. In fact, this is the image without this RBC, and you can see this interference pattern without any curvature. But whenever there is some RBC somewhere here, there is a curvature effect. That is this is the three-dimensional signature. Okay, so this is the hologram without the RBC, and this is some hologram with RBC, and these are the RBC locations. And then we use this as input to this program, and you use this input to this program. So this is in fact the same steps which I have explained mathematically. Acquire the image, make it 2D Fourier, fast Fourier transform, then remove this DC term and plus 1 order term, then take to this center, then make a inverse Fourier transform, and then calculate this phase. So as you can see here, when you will make a 2D Fourier transform, you can get these 3 images. If you can see here, this is the 0th order, this is +1, this is -1, and finally you have to clip this, you eliminate this plus and plus one and the central term, and you have to take this minus one term, then you have to take this to the center and then make an inverse Fourier transform. And when you will make an inverse Fourier transform, this is what you will get, and this is in fact the phase. This is the phase of a single RBC, this is the phase of another single RBC. Then you measure this phase, and the phase which you are calibrating here, you are finding here, is something related to the blood glucose level or the HbA1c level. This is exactly what we have done. We have collected the sample from different diabetic patient. We have mentioned this age, sex, then fasting blood sugar, then HbA1c, what they have calculated in percentage, and you have calculated this in terms of this average phase. So what we are trying to do is, we are trying to give a critical value of this average phase, so that you can say that if your average phase of this is something less than this critical value, you are safe. And if your average phase is more than that value, then you have to go for medication. Similar to that, if your HbA1c level is more than 6.5%, then you have to take medicine. And if it is less than 6.5, then this blood glucose level is under control. So this is the sample which we have recorded. In fact, we are trying to validate this since long, and in fact, these are some of the sample reading. You can see this is the first blood sugar, this is the HbA1c what they have provided us, and this is the average phase value what we have calculated. And just to mention you here, you are using Python program. So we wrote some program in Python and we have implemented this. Now to give a concluding remark, the algorithm which you have used for this reconstruction can be improved by using some image segmentation algorithm. For example, you can use some watershed algorithm, which you are trying to do that. And similarly, you can also increase this accuracy of measurement, because the linearity, in fact, you have to find whether this measurement having linearity or not. To improve the linearity, you have to also use some machine learning. In fact, to get rid of this error, you can also use machine learning. In fact, we are also trying to use some method by which you can reduce this error which you are getting. So these are the different directions which are working now, so that the accuracy of the measurement can be improved. So this is what I have planned to share with you. Thank you very much for giving this opportunity to share something about our work. And finally, let me acknowledge this funding agency, the OHEP, who has funded this center, a 3 crores fund they have given for 5 years, and DST Feast and the Department of Atomic Energy also funded in terms of Rajaraman Fellowship. So these are the funding agency without whose help this work have not been possible. Thank you very much. And if you have any doubts, queries, and can. So, am I audible?
Yes, sir.
Yes,
Okay.
sir. Yes, sir. You are audible, sir.
So, if you have any questions, doubts, queries, most welcome.
Audience, do you have any questions?
Sir, hello.
Yeah.
Good morning, sir. Sir, this is Ashish Tiwari from the Department of ECE.
Okay.
Sir, actually, I have a question for this. Technology-wise, whatever you have shared, that is quite commendable. And I wanted to only ask one thing: whether the government hospitals they're having this kind of facilities or not. I mean, sometimes we move to government hospitals and
No. I actually not follow your question. Whether the government hospital has this facility or not.
Yes, yes, sir. Yes, sir.
See, as I said, the government hospital, they have an instrument called as HPLC.
Okay, sir.
And now they are, measuring this HbA1c level using this HPLC. Okay. And as I said, the cost of this equipment is something 5 to 6 lakhs.
Okay.
So if you go to ordinary pathology center, they may not actually take this test, HbA1c test. So they may send this sample to any other pathology center. Then the question is, can we make some low cost equipment to measure this HbA1c so that the equipment can be, hired by anybody, any pathology center? Because as I say, the cost of the proposed equipment is 20 to 25,000. So with this low amount and less amount, anybody or any pathology center can go for that. Now, as I said, this is in the validation stage. In fact, there are different validation stages in our, we are actually in validation stage 2. Okay. So once it is validated, then you will say that you can take this equipment and you can go for detecting this, HbA1c level.
Okay, sir. Okay. Thank you. Thank you so much, sir.
Okay.
Thank you, sir. Thank you very much for giving your valuable insight in the area of digital holography, its recording.
Now can I leave?
Yes, sir. Yes, sir.
Okay. Thank you.
You can leave, sir. Thank you, sir.
Okay.
Organizers, I think the mic has been muted.
Sudeep, please unmute your mic.
It's not working, Sudeep.
ICSST mic is muted. Please unmute it.
Hello?
Yes.
Yeah, audible now.
Okay. Dear participants and attendees, I am profusely elated to introduce our guest of honor, Dr. Bijayananda Patnaik. Dr. Bijayananda Patnaik is working as an assistant professor and PhD program coordinator at IIIT Bhubaneswar, Odisha. He has completed his PhD degree from Indian Institute of Technology, IIT Bhubaneswar. He has more than 16 years of teaching and research experience. He has guided 4 PhD scholars, 19 MTech students, and many BTech students till date. He has established optical communication lab at IIIT Bhubaneswar for MTech and PhD scholars. He has successfully finished a sponsored research project on establishing remote communication for solar lanterns. His present research interest includes 5G and photonic technologies, optical signal processing, nonlinear optics, smart system design, green communication, etc. He has published more than 50 research papers in various international journals and international conference proceedings such as IEEE, IET, Springer, etc. He is also the editor and co-editor of various international journals and books. He has also reviewed various research papers of IEEE, IET, Springer, etc. With immense respect and honor, I warmly welcome Dr. Bijayananda Patnaik to throw some light on the smart and sustainable technologies. Sir, please.
Okay, good morning to all of you. I think I would like to thank Ashish. I think your name is Ashish? For
Sudeep, sir.
Sudeep, okay.
Yes, sir.
For nice introduction. And I can tell from the beginning that I would like to thanks to all the organizers, all the members of this conference, that conference ICSST 2021, as well as the management to give me this opportunity. Okay, today my talk is, just I will share the screen. So I think my PPT is visible. Am I right? Any one of you please
Yes, sir.
coordinate.
Yes, sir.
Yes, sir.
Ranjita
Visible,
madam
sir.
is there. Okay, sure. Thank you. Any one of you, Ranjita madam is there. It's okay, good. I can tell in brief about me also what he has given the introduction. That is
Sir,
the
sir,
maybe.
BN sir.
Yes, madam.
Sir, good morning. Sir, kindly go for the full screen, sir.
Full screen, okay, madam.
No problem, sir. You can continue.
Is it working, madam?
No, sir. No, sir.
Not working. Already I've done here in my laptop.
Sir, no problem, sir. You can continue.
Okay,
We are
let
able to
me-
see.
Okay, just one. Slide is changing.
No, sir. It's constant in the first slide only.
Okay, then let me see.
Yes, sir. It changed to 4, 5. Yes.
Now it is changing, I think.
Yes, yes. It's changing, but not in full screen.
Full screen.
You can continue, sir. No issues.
Sir, kindly click on the one which is beside the 60%, the slideshow.
Already I clicked. It is not working.
Okay, sir. Sir, you can continue, sir. No issue. It's visible. Yes, sir. You can continue.
Okay.
Okay. Thank you, sir.
So I am well associated with this GIET University. Huh? All of you know, I think all faculties, organizers. And I was working there itself since 2003 to 2009, around 6 years. No doubt after that I am in there in IIIT Bhubaneswar since last 10 years. But I have a very old as well as good association with the GIT University. And also I would like to thank for giving me this opportunity. So today I will be discussing about this green photonics. What are the trends and opportunities? Okay. So I think you in this conference the major theme is you are the about the sustainable technologies, green technology as well as smart systems. Since I think 3 day I have seen a lot of invited speakers, very nice arrangements and all those you might have be familiar with something. But still as it was informed to me that most of these participants are only UG students. So that is why I modulated my side or the talk towards the UG students. No doubt, as far as the opportunities as well as challenges will go, some PG as well as PhD scholars as well as faculties, those who are working in optics, okay. And what is green technology? I think all of you know about it. The outline of my presentation is the green technology and what is green photonics technology and what is sustainable economy, 5G technology, fiber and free space optics, challenges in optical systems, optical DW, some simulation I will show, some results and discussions, conclusion and key references. And time is less, that is why I will go bit fast, but still anybody, any doubt anywhere you can interrupt. Okay, thank you. And green technology, already you might have listened since last 2 days. It is nothing but the environmental friendly technology. The technology, whatever we will develop, nowadays people are talking about a lot of advanced technologies. But all the technologies are not green because it is not environmental friendly. And all of you know at present also government is declaring a lot of things about this environment. Like last Diwali also, we need to use the crackers, which is a green crackers only, because environment is polluted nowadays like anything. That is why with the development of the technology, we should also take care about the environment. And if you can able to take care with the technology, this environment also, then it is called green technology, which conserves the natural environment so that it will not have negative impact of any human being. All of you know in Delhi, and now schools are going to off, this is off, that is off, work from home and all those because of this environment pollution. That is why people are working hard in developing the technology. That is why side by side they need to take care about the environment also. That is the major aim. And it is also used to energy generation technology. It is not that green technology means only environment friendly, as well as the technology you need to develop in such a way that what it will also be useful for the energy generation. Whatever the energy it is generated, that should also be generated from the environment, like solar energy, wind energy, renewable energy, which is more popular nowadays. Because if you use the coal and all those, time will come we may not able to get the petrol, diesel, all of you know, which is finite, which may not you may not get in future. That is, if you at all will dependent upon this only, we cannot survive, or the technology cannot survive in future. So that is to be taken care. And what is the need of the day? As far as all this communication is concerned, today I will highlight mostly on communication, because which is a present scenario, the highly great demand. And in simple, what is communication? I can tell, if there is no communication, there is no life. As I think so many students are there, when you are staying in the hostel in GIT Gunupur, you people are what? Every day, 2 to 3 times, you are connecting with your parents. You are getting information in the television, the news, and all those. These are all communication. If you will not talk 1 or 2 days with your parents, you cannot stay at your workplace, and your parents also cannot stay. So that is why the communication is becoming such an important requirement in the present scenario. But without food, a human being can survive. In other sense, I want to tell, but without communication, you will be fully tensed. You cannot move ahead. So that is because communication is becoming an important aspect in the 21st century. So we need to take care how it will be much more advanced, as well as how it will be it can be sustainable in the near future, taking into the consideration of environment. So high system capacity, what is the in the present and next generation, what we need is the system capacity. System capacity means whatever the system it has, the system capacity is to be means in simple, we need to go for very high speed communication. When you are downloading a data in a YouTube, I think you know, if you will go for 3G, it may require 10 minutes. If you will go for 4G, it may require 5 minutes. When it is reducing, when the speed of download is increasing, as we are going for generation to generation in a communication system. So in 4G, we are getting bit faster. In 5G, definitely it will be more faster. That is why we can tell the system capacity or the system speed is increasing. And network coverage, you know about the network coverage, very simple. Anytime, anywhere, we need the network in a communication system. It is not that you want to talk with your friend, means you need to go to a land phone. We need a mobile phone. Wherever you will there, we need to connect at any time and any place. That is what the requirement. And some places it is still uncovered because of the technology which is advancing and taking care throughout the globe. But mostly, as far as the cities and towns, it is there the network is available. But in 5G or in future, it is expected that each and every place of this world network should be covered, because we need to go for IoT technology, Internet of Things, where all the things should be connected to internet. Some of the examples I have written for more bandwidth applications are real-time video conference, image transmission, communication for everyone at any time and any place, human to machine and machine to machine interaction. You know, when one machine is connecting with or interacting with other machine, which is nowadays equally important, we are doing very high bandwidth is required. So you can tell the demands. If you'll see the user demands, these are certain the examples I've given. Whenever you require the mobile internet anytime as well as at anywhere, like inside the building, we need the high-speed connection, internet connection. Outdoor also we need. When we are walking on the street, also we need, as well as driving. When people are moving in a car or in a vehicle or a very high-speed train. Basically, the high-speed train means at present what it is there with a speed of 300 kilometers per hour. In that high-speed train also, we need a reliable as well as high-speed internet, which is our requirement. As well as subway also, we need this, which is our demand. So this is what in a system based, when we will go for a lot of things we do have surrounding to us. So all these things should be connected to internet. That is what our requirement. As well as autonomous driving. You know, without the driver, how the vehicle can be moved from the source to destination or from one place to another place without driver is a challenge, which is our requirement. Another is remote healthcare. If there is a very good doctor, maybe in America, in India, we need the help of that doctor. So the doctor should communicate or should have the facility to diagnose the patient, to do the surgery, to do the any kind of suggestions for the what patient in India. If you can see those kind of environment or a scenario, then it is called remote healthcare, which is also highly required in the present scenario. as well as a drone based delivery. All of you know what is a drone. So if the delivery like what they now they deliver Amazon, this what a lot of things they are coming delivering the items, and because of COVID we don't want to touch any person. We are very, they require very secure, as well as we need to be ourselves very much hygienic. So that is why it is thought that if the delivery and all these things can be done by a drone, you can imagine how much bandwidth is required, how much power is required, and that is what the future requirement. By looking to this thing simple, we can tell only one thing, that all these things to be operational means we need very high power, and from where we will get that high power, that is what our aim. So that power is to be generated in such a way that it should be environment friendly. That is why people are thinking more about solar energy, wind energy, and all those. As well as this system should consume very less power. Then only whatever the power with available with us, we can, with that power we can get all the facility. You can take the example, if you have a mobile phone, so you are using all the apps. In a daytime, it will require 4 to 5 times. It is required to be charged. You will be unhappy. So that is why we need that the telephone or the mobile phone should be charged very rarely, once in a daytime. So it means it should be power efficient. If it is power efficient, then you need to develop the technology in such a way that with all the apps to be used, the requirement or the power requirement should be less. And what I can say, in all these aspects, photonics or the optical systems plays a major role. And I will briefly retain all of the, you know about it, but still because of the UG students, I don't know what is a photonics. Photonics is the science of light, which is nothing but photon, well known to you, which is the generation of photon, detection, manipulation through emission, transmission, modulation, signal processing, switching, amplification, and sensing. So all these things, if you will do what we are doing in electronics, if you will do upon photon or upon light, then it is called photonics technology. So, and most of the photonic applications are in the visible and IR range, near IR range. And it was basically during 1960, it was developed, small photonic systems. Later on, because of this revolution, like optical fiber, which is developed during the 1970, and this optical system becoming very, very what a tremendous use in communication after 1970. I will, in the subsequent slide also, I will show you how photonics play a major role. Then optical system, basically the major advantage of optical systems are optical power and bandwidth are two important resources of any communication system. As well as the optical system basically uses lasers and LED. All of you know LED in your laboratory, it requires very low power in the range of milliwatt. But if you will go for RF technology, it requires very high power, kilowatt, megawatt. No doubt it is well established, but still also it requires very high power. If it is high power, then you know in future we are in doubt whether it will we can accommodate those technology or not. That is why optical systems are becoming important, because it consumes low power. Why low power? Because it uses laser, LED as optical sources, and you know laser LED can provide very what efficient communication using very low power in the range of milliwatt or dBm. You can tell, as well as it has a very huge bandwidth. Another advantage is the laser signal works in terahertz. So that is a hundreds of terahertz of bandwidth, means very high speed communication, high speed facility we can get by using this optical system. That is why it is widely accepted. And millions of dollars are spent for lightweight technology to the results of its performance. And that is why people are spending a large amount of money for getting or for making these advantages. And you can tell optical systems means the what laser based system or the LED based system, or you can tell any manipulation upon the light. I think just previously Professor Tripathi has highlighted about also the laser technology, how it is used in medical applications. So that is why no doubt he has highlighted. Today I will tell, now I will tell about this what communication perspective. But what I mean to say, the optical system plays a major role in green technology. And why green technology? I have written in brief that energy consumption is also increasing day by day. Energy efficiency is also required. And researchers concluded that mobile operators are among the top energy consumers. The energy mostly it is consumed by the mobile operator. That is why you need to take care in communication system in such a way that it should consume low energy or low power. I have given a what figure in 5G it requires 100 times comparing to 4G, where basically it is instead of 4G, if it is 10 milliwatt per Mbps per second, it is increasing 1000 milliwatt per Mbps per second. That is why you can easily imagine 100 times. No doubt the speed is increased. In 5G, basically we are using 1 Gbps of data rate. No doubt in 4G, it is 200 Mbps. The data rate is increased 5 times. But in the same way, the power is increased 100 times. So which is not at all acceptable in future. That is why we need to, people are working hard how to make this optical technology to be a green technology. With increasing energy cost and power consumption, wireless lead to a environmental problem will be coming, which I've already told. Thus, for the sustainability, mean this technology to be which is providing a lot of advantages. If you want to continue in future, then green technology is a must. Means you need to take care about the environment. And the green photonics, if you will go, what is green photonics? The photonics technology that can generate, conserve energy. Greenhouse emissions, already know greenhouse effect, CO2 gas, the carbon dioxide which is emitted, which is harmful, those things should be reduced, reduce pollution, yield environment suitable products. Increasing significant role in reducing the environmental effect. Photonic technology plays a significant role, which already I told you. As well as whenever we are going for eco benefits, and product design, manufacturing, and laser has a lot of applications. You can tell like what I've given, the laser manufacturing, solid state lighting, solar cells, optical communication, and you can tell the examples like nowadays by eye surgery, the cancer operations, the welding technology, augmented reality, AR, VR technology, autonomous drive or LIDAR. All these are examples of this photonics technology, and which consumes very low power because laser works in milliwatt. That is why it is to be researchers are working hard to get the sustainable technology. Photonics plays an important role. Again, I've written some of these green photonics. 20% of the power what we are using at present is only for lighting purpose. So that is why instead of in a day-to-day life also we are using, if you use the LED or organic LED, what is happening? 50% of energy is saved. And because it is with the CO2 emission is also reducing, and which is equivalent to 600 million. That is why it is advisable that people should use LED or OLED technology instead of all other technology in our lighting purpose for available or for the technology to be in green. So use of light helps in various aspects of the optimization of plant growth. Light is not only used for communication. Some of the other applications also I have written, like optimization of plant growth, sterilization of drinking water. In our day-to-day life, we are observing laser surgical operations. Already I told you, like eye cancer, a lot of operations are going on. Industrial welding, efficient high-speed communication, sensing weather parameters. So these are what that is why the leading scientific concern in the 21st century, the green photonics. And 90% of the data transmitted in telecommunication are by using optical fiber. So that is why optical fiber is important. When you can tell our communication or whatever using mobile phone or internet, what is happening, 90% of the data is only communicated using the use of optical fiber. That is why it is what, or you can tell any communication system, modern communication system, if at all it is developed, and you can tell a part of it is not a optical, then it is not said to be a modern one. So that is why you can tell the optical communication or optical fiber optics is a must in modern communication system. And storage media, other applications like microprocessor are also nowadays, it has been designed by using the optical technology. Laser techniques are used for welding, manufacturing, photovoltaic, solar energy. I think all of you know about the solar energy also. So that is what I mean to say. The optics plays or the photonics technology plays a major role in communication system. And about the sustainable economy, in the economic point of view, if you will see the photovoltaic contribution to the sustainable economy, one is the energy generation, what I told you, like solar energy, reduced energy consumption, like if you use solid state lighting like LED, OLED, as well as the communication by using fiber, definitely the energy consumption will reduce. Then enable eco-friendly design and production, which is the what eco-friendly means, again it should not be going for the environment pollution, and reduce risk of potential. Another aspect nowadays is security. I think all of you know we are using the mobile, internet, banking, and all those. Security is an important aspect, and the secure for security purpose, the photonics technology plays a major role. So this is what about in brief about the communication system. No doubt the UG students, they may know already studied, but still I will briefly tell what is a communication means. Transmission of information from source to destination. In between, what we do have is basically called communication channel. So that is what I'm telling you. If a communication system means, you have to understand there is a source, or that is also called transmitter. There is a destination, is also called receiver, and in between source to receiver, what do we have is called communication channel. And what I mean to say here, what do you mean by optical wireless and optical fiber optic communication? Basically, fiber optic or optical wireless means the channel. The channel is nothing but a in the channel we are using laser technology, and maybe using optical fiber, or by using free space, the communication is achieved. And at present, people are talking about, or the latest what we require is the 5G. And we will go for the very brief about the introduction about the current generation 4G. In your mobile, you might have seen LTE is the standard long-term evaluation. If from first generation to 5G 2022, we are expecting that it will work with 100%. So till now, certain parts of 5G is already developed. So 1G was only analog, then comes to digital, and then digital broadband, mobile internet, more faster we are getting at present, but we are expecting in 5G bit more. What I told you, the autonomous driving, drone-based delivery, and all those. Pull from user demands in 5G. If you will see the 5G, what we require is much faster, around 10 Gbps is the minimum data rate speed with a latency. There should not be any delay. Less than 1 millisecond delay is required. Super connected, 10,000 traffic or thousands of traffics are to be connected with the devices. High mobility, 300 kilometer per hour when we are moving in a train, then also should get the facility. Ultra reliable means if you are getting a connection, but it will be disconnected multiple times throughout the day. No doubt, if at all it is speed, then also it is not suitable. That is why highly reliable, 99.999% reliability of this technology is required. And energy efficiency, already I told you, it should require very low power. Then in brief, I will tell about the optical systems. It is not only the optical means, don't think that always it is fiber optics. It may be free space optics or hybrid optics also. In the present scenario, so hybrid optical becoming more demand because each and every system has its advantage and disadvantage. Taking into the consideration of fiber as well as free space, hybrid optics is becoming more important. Because the time is less, I will just go briefly. So any doubt you can interrupt. I cannot go in detail about it. Advantages and disadvantages of fiber optics, I think all of you know about it. The greater bandwidth, susceptible to signal degradation is less, and low power transmitter, weight is less. These are the advantages. This you can go in detail. And what is free space optics? Just I will tell the brief. From one building to another building through using a laser without any optical fiber, if you will communicate, then it is called free space, because this using free space we are communicating, that is called free space optics. And this is what basically typical setup how the free space optics works. There is a transmitter and receiver, and full duplex communication is carried out in between transmitter to receiver, so that the user can able to listen as well as user can able to also tell parallelly at the same time. And the major advantage of the free space optics is it provides the last mile bottleneck problem. So no doubt throughout the globe we are connected with fiber optics, but at the end, if you will not use free space optics, it cannot be connected to our desired internet or desired PC or desired device. So that is why free space optics plays a major role from the fiber to the device. And this is what also a typical setup where I have shown the how fiber optics or the free space optics is connected. And this is the fiber, which is nothing but the backbone, which is working at present with 2.5 to 10 Gbps of speed. And you can tell why not we will buy more fiber, because it is why free space optics. The major is cost is less, and rights of way, permission, trenching, these are all the headache in fiber. So that is why best people go to free space optics. And one of the major advantages of free space is it can be established within no time during the disaster, during the cyclone, whenever the communication is required at a faster rate. Then basically people usually prefer free space optics. And requirement of good 5G, or it may be 5G or 6G wireless system, it should have very high bandwidth for getting very high speed, low bit error rate, high SNR, power efficiency, data security, low cost, as well as installation and maintenance. Then classification of free space is also classified into various categories. One is terrestrial, and there is space. Terrestrial means ground based, from one building to another building where communicated. Similarly, the free space optics is also plays a major role in satellite, where it is called as a space FSO systems, where one satellite to another satellite or from satellite to ground space, the communication is also achieved. Then advantages and disadvantages of FSO. Similarly, you can go through it. We don't have time, so that is why we will go where it is delivered certain parameters. Of you can see the major challenge in free space optics is this one. You can see the attenuation is increasing from 6.5 dB per kilometer to 225 dB per kilometer, which is completely very huge. So that is why people are working hard how to go for a technology which will work at 6.5 dB or with a clear weather condition as well as a foggy condition, where during winter, if there is a fog, then FSO fails. So that is why you cannot get a reliable communication. For getting reliable communication, you need to take into this scenario. And atmospheric turbulence. So now we will go for certain challenges, because I'm planning to complete within 10 minutes. Other talks are there. And telling is very easy, I do understand, but listening is very difficult. So that is, I will not take most of your time, but still I will highlight what work we are doing and what is its importance in the present scenario of this green technology as well as smart technology. So challenges in optical system is eco-efficient design, what I told you, environment friendly. Fiber non-linearity and dispersions are also the challenges. Intelligent fiber optic network, this is what smart system, people are talking about smart system. So that is why the network should be intelligent enough. Improvement of optical amplification technology, advanced modulation, equalization, coding. Each and every topic is a very itself is a huge topic chapter itself. So you can go in detail. If any one of you can take any one of the problem, it will lead to a very good research paper as well as PhD also. So that is, I have written only briefly about the challenges in photonics or optical systems. So misalignment, building sway, ambient light, the background light, beam divergence, atmospheric turbulence. Already I've written earlier, or I'm not describing it in detail. Absorption, scattering. But what I mean to say, no doubt optical plays a major role, but it is also a lot of challenges. So that is why researchers are working hard how to mitigate the challenges. Then, no doubt we have studied about the theories. I will show you some of the simulations, edit setups, so that if you practice these things, you will really implement, or you can tell this is the implementation part of this photonics technology. And if you will implement this, you will have the confidence that we could also do something for the technology. That is what I will show some simulations as well as results. So this is what a typical WDM means, wavelength division multiplexing setup design in a software that is called Opti system, where lot of means around maybe 1 to 4 channels are connected through a fiber, as well as the receiver. It has been recovered by using this pin diode as well as low pass filter and bit PER analyzer. Clear? This setup you can design in Opti system. And I will show you some of the results so that you people will be interesting to work upon this, and you can have the confidence also that we could able to do something as well as you can contribute to the technology, what I told you. So you see here, I will show the spectrum. All of you know wavelength versus the power. If at all you will see the graph that is called the spectrum, where figure A and figure B. In figure B, you can see the power is very less. Here in this case, it is around minus 60 dB. Spurious signal, undesired signal power is minus 60 dB, where it is minus 30 dB. That is why figure B is better, because undesired signals are less in figure B comparing to figure A. And in a communication, we require that undesired signal should be as less as possible. That is why by you simulating those software, you can get this result. As well as there is a column called OSN, or optical signal to noise ratio. I think you people are know about the SNR of a communication should be as high as possible. Here in this result, you can see this left hand side it is around 29, 30, but right hand side is 32, 35, 36. There is a nearly 3 dB improvement in the OSNR because of the system that is called MDRZ modulation. So that is why you can tell CSRZ is not better comparing to MDRZ. Just to highlight certain results, I have shown it. Similarly, if you go for an optical system without dispersion compensation and with dispersion compensation, how the eye diagram looks like. The right hand side, the eye is very clear, means the information can be extracted very easily. So that is why you can tell dispersion compensation is a must in optical systems. Like this, here we have plotted the graph between input power as well as Q factor, and you can tell the MDRZ provides better result. And what is Q factor, bit error rate? I've written the equation. Q factor means quality factor. So the better the quality factor, the better will be the communication system. And you can tell here the power in a system is very high. It is also inefficient. If it is less also, it is inefficient. That is why you need to choose or you need to go for optimized value where the power should not be too high and should not be too low. Next is you can go for the dispersion compensation. There are various dispersion compensation in fiber optics, symmetric, pre and post. Out of these three, you can tell symmetric compensation provided better quality factor comparing to other two. This is what the typical result I have shown, so that if anybody is interested, you can work upon this. As well, this is also the eye penalty with respect to different channels. The center channel, the eye penalty is less comparing to other channels in a DWDM system. Next, already I told you now the communication is not only the any one, hybrid communication is becoming very, very important because of the advantages and disadvantages of one over another technology. So hybrid means what you can, this is what the typical setup I have shown. The input is a wireless system, the in between there is a fiber, and after that again it is wireless. That is called diffused link. So if you combine wireless plus fiber, again wireless, then basically it is called hybrid optical system, which is becoming nowadays important. And that is why, as per the requirement, hybrid systems are becoming more popular. Certain results of these systems where I have simulated and we got the eye diagram where you can see at 500 kilometer and another is 950 kilometer. And this figure 1A is better than 1B. As the distance increases, I will be distorted. Similarly, you can go for this different channel spacing like 100 gigahertz and 25 gigahertz, how it is working. Similarly, the FSO systems also we can have the graph with respect to this input power, how the coverage distance, as the power is increasing, coverage distance is increasing, as well as QPSK provides better result comparing to OOK like NRZ and RZ techniques. So that is why in our basically communication system, PSK technique or phase shift keying technique plays a major role comparing to on-off keying technique. You can tell why it is on all these things. I think you might have studied. And at last, I will go for the conclusion that what is green for the photonics technology. I have highlighted, and 5G technology, something about the communication and its importance are discussed. Challenges in optical systems and in mitigation techniques are analyzed. FSO technology is to be applied to last mile. Already I told you throughout the globe we have connected fiber. At the end, we need to connect with the device, means we need to go for FSO technology. And some results of fiber optics systems are analyzed. So the certain references which we have, I have used, I've written. We have also the published. We have one of the paper in optical engineering during 2020, which you can go in detail. Which is our one of my scholar Jagan Bihari Padi, who is working as a faculty in GIET. He has published it. So that is why if people are interested, you can work upon it and publish papers. So these are certain key references I have written. So I think very briefly, I have concluded my talk. So now I will be happy if anybody will be having any questions, any doubts about it. Over to you. Please, any other questions?
Good morning, sir.
Good morning.
Sir, this is Mukesh Kumar Behra from Electronics and Communication Engineering branch.
Good.
I am a fourth year student and I am also researching in this field, optical fiber communication.
Very
Sir,
good.
you have said in slide 12 the adoption of LED. Sir, can LED replace the place of laser in the optical fiber communication?
LED replaces laser. You see, if an LED is used, I think then some noise is coming. All of you please mute. So LED cannot replace the laser because laser is coherent and which is useful for high speed communication. If you want to communicate the data with 1 Gbps, 10 Gbps, 100 Gbps, laser is only the optical solution because it is coherent. But LED is not coherent. That is why for few data rate like 10, 100 Mbps or maybe maximum 100 Mbps, 10 Mbps, 50 Mbps, you can use LED. But what I mean to say, this LED and OLED, what I am telling is about the lighting purpose. What are using the LED TV or in our day-to-day house, home appliances also what are using the LED, that LED I am talking about. But if you will go for high-speed communication, then we need to go for definitely the laser technology only. Okay, is it clear?
Yes, sir. Sir, another one like in dispersion compensation methods, we are using various methods like dispersion compensating fiber and fiber Bragg ratings. So, which will be the
Right, very good question. I really appreciate FBG, fiber Bragg rating is the best among all. But what is the major problem is FBG when you will go for multiplexed system, because for utilizing the spectrum of the system like spectral efficiency is to be more, then we need to go for multiplexed system. And when you will go for multiplexing system, utilization of FBG is a challenge. But if you will use a single system, then FBG will be better comparing to all other. That is why in multiplexer system, it is the problem. We are using symmetrical dispersion compensation technique. Clear?
yes, sir. Thank you, sir.
Sure. Thank you. Very good. Any other doubts? Any
Hello,
other
sir.
queries? Yes, please.
Sir, my name is Pritam Jana and I am a third year student of Electronics and Communication Engineering.
Very
Sir,
good.
I am working with OptiSystem software now, and sir, my research area is single mode fiber and sir, dispersion compensating fiber. Sir, can you tell me how can I implement this photonics in my research, sir?
What you are using the optical fiber itself is a photonics technology. Got it?
Yes, sir.
And one more thing, what I mean to say, when you are doing the dispersion compensation technique, clear? So
Yes, sir.
try to, the present trend is, so if at all use very high dispersion like positive dispersion, negative dispersion fibers are available. So you need to tune the dispersion of the fiber in such a way that it should not be too high, it should not be too low. If dispersion is negative, then the pulse will be compressed. If the dispersion is high, then pulse will be broadened. So that is you can use one of the optimization technique. Clear? At
Yes,
present, a lot of optimization techniques are coming. You should tune the value in such a way that dispersion should not be too high, should not be too low. Clear?
okay, sir. Okay, sir.
Good, good. In Opti system also, optimization techniques are available. You can see and you can simulate. Okay.
Okay.
Good.
Good morning, sir.
Good morning.
Okay, sir. My name is Swagat Kumar Patra, and I'm a ASM student. So, sir, my question for
Good.
you is, what is the scope of hybrid FSO in 5G?
Right. You see, a hybrid FSO means we are not using FSO only. With FSO, we are using fiber. You see, for example, if you will tell, I am talking in a telephone. From my telephone to the nearest tower, which you can tell fixed station, with only the communication is wireless, where that is called base station. Basically, in a mobile environment also, you will see from mobile phone to base station, it is wireless. From one base station to another base station, basically it is optical fiber. And again, at the destination, if I am talking with you at Gunupur, in Gunupur also you are using a mobile, but from Gunupur to Bhubaneswar, it is not completely wireless. It is wireless. Then from base station to Gunupur base station, it is fiber optics. From Gunupur base station to your mobile is wireless. So it is a wireless plus fiber optics as you are using. That is why it is called hybrid communication channel or hybrid systems. Clear?
Yes, sir. Thank you.
Very good. Okay, any other queries?
Thank you, sir. Thank you for sharing your valuable insights in area on green photonics, green technology, optical system, which can motivate us.
Okay, thank you. Thank you all for giving me this opportunity So thank you all. Bye bye.
Thank you, sir. Dear participants and attendees, we are having a great opportunity to listen to the words of great knowledgeable scholar, Dr. Ajit Kumar Panda. Dr. Ajit Kumar Panda received his PhD degree in microelectronics area in 1996 from Sambalpur University and was postdoctorate at University of Michigan before joining National Institute of Science and Technology, where he is a professor now. He is awarded with ICTP Regular Associate Award for collaboration work with ICTP Microelectronics Laboratory. He has visited countries like USA, Italy, Germany, France, Singapore, Hong Kong, Malaysia, Nepal, Bangkok on different academies assignments. He has published more than 70 international journal papers and presented his work in more than 100 international and national conferences in the area of semiconductor devices, VLSI circuits, and COPE in 3G and 4G microwave engineering. He is a coordinator of NIST TFAC core in 3G 4G Onion Communication Technologies, which has established a funding of around 10 crore from DST, Few Industries and NIST. He is a member of IEEE, member of VLSI Society of India. He is a regular reviewer of more than 10 index journal including IEEE, IIT, etc. He has organized more than 30 conferences at NIST and other places. He is the co-author of book named Physics of Semiconductor Devices and has successfully completed 6 projects funded by DST, UGC, MSME, and MHRD. His research interest includes semiconductor, heterostructure devices, VLSI circuits, microwave, MI integrated circuit, and communication technologies. He has obtained Odisha Technocrat Award for 2015. Recently, he has been appointed as one of the Dean of BPUT and is a member of NAS Assessment Committee. He is a distinguished lecturer of IEEE Electron Device Society. With immense respect and honor, I warmly welcome Dr. Ajit Kumar Panda to throw some light on the smart and sustainable technology. Sir, please.
Yeah. Good morning. Thank you for introducing Anchor. But
Welcome.
is it audible? Yeah. So, but slightly I will modify the biodata. I think is the old one. I am not working now at National Institute of Science and Technology. Actually, it was the previous one. Actually, now I'm a open basically and working for the industry as a different positions and different names actually. So let it know, everybody should be clear that I'm now not a professor actually, and not the coordinator for the type of core and all that also. That was there in previous. For last 2 years actually, I am associated with different industry as well as my own startup. With that actually, Mr. Anchor, can you allow me to present? Can I
Yes,
share
sir.
my screen? Yeah, sure. Thanks. Yeah, I'm sure it is visible to everybody, right? Yeah, it is visible, I think. So anyone can, stop at
Yes,
any
sir. It is
time.
visible, sir.
Yes. So anyone can stop at any time and basically, can ask any questions if it is there. So the topic, as you guys told it, the 2G to 5G, and slightly I have modified it, given to that given abstract actually, because I saw that you are looking for smart and sustainable rural areas basically. So when I look for that and I listen the last few slides of Dr. Vijayanand Patnaik, who was talking about these fiber communications, where actually he was talking about how to reach to the base station actually. Till the base stations, the fiber is connected, and from base stations actually it goes to the base stations from where actually the fiber end actually. From there actually our work starts, and there actually the radio unit placed, and that radio unit actually gives the communication signals on Wi-Fi. Therefore, I will try to touch that part. So it is a good basically that you understand it till the fiber, how it reached up to the base stations and what happened actually and exactly at the base station. That I will try to cover it also. So quickly I will go through. So anywhere, if anyone is interested to ask any questions, can stop and can ask it also. I will go quickly, and I will prefer to have more times of the discussions. So when we talk about the 2G to 5G rural areas and all that, actually the evolution of mobile phones and communication started actually from 1980 onwards. Whereas in Odisha basically we started around 2000 2001 actually 2000 2001 with the GSM and till now of course in rural villages GSM is there, but in few places already the 4G and 4G is also working. I'm not sure actually how actually it is the 4G signals at Gunupur and all, but in Bhubaneswar, or let's say suppose the city in Odisha, we are able to get the 4G signals, those who use the Reliance 4G type, and it is expected that this 5G. If you look at today's newspaper, the Morning Times of India, basically, if you look at where actually our Honorable Minister Ashwini Vaishnav, Communication Minister, again from Odia, who has told that the 5G will be implemented in India in October 22. This is the today's news actually. Even if you read it, Sambada newspaper, it is written, it is mentioned it actually. So 5G is on the development stage. It is developing. It is on the testing stage, but I think will be available to the public around October to December 22, and I'm not sure actually whether it will be available to rural areas or not. But till now, the rural area is using the 2G spectrum, no doubt on that actually, and most of them are using the GSM mobiles, except few maybe that 5% to 10% might be using the smartphone, but most of the people are using the 2G. And what exactly the 2G was there actually, depending upon the frequency bands and all that actually, at what frequency and what wavelength and all that actually it is operating. Based on that actually, if you look at the VLF, LF, mid frequency, where the radio signals and all that transfers, the VHF, where actually the UHF and all that actually. In all these cases, my one point is actually, one point which actually I was talking to in every talk actually, whether it is 4G, 5G, whether it is 2G, whether it is radio, whether it is the maritime radio navigations, or maybe that, AM radio, in each of these cases actually, the electronics engineers have the lot of roles. Electronics and nowadays, of course, the computer science engineers, and in all these cases actually, analog is one of the main part actually, and RF design, radio frequency design, which actually we call it in the syllabus in 6th or 7th semester as the microwave engineering actually, microwave engineering. In all these cases, there is a major part actually, and unfortunately, we usually avoid that part actually. So because I saw that on the audience many students are there, therefore one of my advice or suggestions, basically I will not say that advice, who am I to give the advice? So one of my suggestions is basically the students will have the good knowledge on RF and microwave engineering if they would like to be a part of these communication systems in any cases actually, be it in fiber optics, be it in the microwave, be it in anywhere actually. That is one of the important part actually. So this is one of my suggestions which actually the people should use it. Anyhow, when we talk about the 2G, in each cases actually the devices used. In each cases the devices used. So that devices basically, again in 2G and all that, if you look at the future one, the impact diode, gun diode are using it, and gradually actually the MOSFET, and now actually the HEMT kind of devices are using it for this type of communications technology. Therefore, but actually I will tell you and what exactly where we fail it actually, I will try to say that. So we have worked on these impart devices way back in 2000 actually, way back in 2000 when actually this GSM was there. At that time actually we were working on the devices like impart devices. For that actually we had developed the models, the DC, small signal, noise, all that kind of models. I'm not going in details of that actually, but that actually lead basically how to make a system. I would like to talk that and how that actually is using it in the rural areas. That actually my motive to talk on this one actually. So for GSM or any devices actually, as I said that you need a microwave devices, power amplifier you need it, a low noise amplifier you need it, and for that kind of things actually impact which actually you might have read it in the books. This kind of diodes is used it for that kind of purposes, and that kind of diodes in 2000 onwards actually we have started working on this, and this kind of diodes actually we had fabricated way back in 2000 2001 when some of you might have not born actually at Institute of Radio Physics and Electronics at Kolkata. But again, why I'm telling it, we remain in the device actually. We targeted it to the make a system for the 2G, but we could not able to do it. And we remain only on the devices. Same things actually on the other, the gun diode. Impact diode gives the slightly more noise. So the people use the gun diode. The gun diode, again the same. DC characteristics, high frequency, and it depends upon the material. And around that time actually this so-called the gallium nitride kind of materials comes, which gives the which has the high power capacity as well as high frequency. It can be used at high frequency, it can be used at high velocity. Therefore we jump to one kind of diode where actually we try to see that using the gallium nitride material, if it will be helpful to generate the high frequency as well as the high power, which can be used it in GSM kind of mobiles. And this is one of the basic structures of the gun diode, which has been used. For that also we had developed the simulation models, and we had solved few things. And we had seen that, as I said, that gallium nitride kind of materials introduced, and we are one of the pioneer actually to work on this gallium nitride kind of devices at that time. Before that, actually, it was using the gallium setup. Again, we fail it here also. We remain only on the device. We could not able to give an applications of this either to rural areas or to communication systems. The next, basically, if you look at, the MOSFET kind of devices games, which actually gives you the idea of the IC designs. So we jump to MOSFET and MOSFET kind of devices, where actually again we develop the software, we study the 2D G effect, the different effects like that of the piezoelectric effect, which plays a major roles in MOSFET or HEM kind of devices that we see it. We observe the velocity overshoot effect, which actually one of the pioneer for the 2D MOSFET, which actually are using it today. And today's IC design, which actually the people are talking, that is basically using a 2D MOS kind of devices, actually 2D MOS kind of devices. So we started working on this and see if we can able to give some system level solutions using these kind of devices. But again, again, let's say 2D MOSFET devices, then all these were in classical. So again, we remain in the device area only. Now then we jump to the HEM kind of devices, and that actually lead into the quantum mechanical devices, quantum mechanical studies. In case of the HEM, basically, I don't know, a few of you guys might have known it, or if you don't know, also just it is basically the confinement of the electrons, which we cannot do it in any impart GON or MOSFET kind of devices, and for which actually the velocity could not able to increase high. Whereas in this case actually the most of the men of the motivated to confine. Usually people don't like the confinement, right? Physically, the general concept is confinement makes mobility low. But in case of quantum mechanics and in our communication systems, actually, the confinement makes mobility high. Mobility high. Therefore, don't afraid to be confined together. be it in jail or be it in somewhere also, hardly matter it actually. So this is a concept of the carrier confinement, which actually did it in quantum mechanically. So if you look at, how actually the quantum mechanically probability theory, you use it and start it. For that also, we develop the model or models, these quantum mechanical models using the Monte Carlo simulation, and we try to study that. So all this basically, on study, basically we remain in the devices only. How actually it will be its applications and how directly I can able to use it in a communication systems, we could not able to make it. Of course, doing this, we did it in a semiconductor communication in on multiple steps. Doing that actually, we could able to give some applications in the device levels, for the X-band radar and other applications, then develop this HAMT actually, which now we are using it in the applications areas like in LoRa and 4G, 5G communications technology. Doherty based this HAMT power amplifier, which actually we design it, is heavily using in RF front-end technology for 5G communications technology. HAMT kind of devices using even in LoRa technology also. So what I want to say, for last 15, 20 years, actually, we tried hard, basically, can able to make and give an applications which actually our research will applicable directly to the rural areas or directly applicable to the systems level that we are, that where actually we did all these works and where actually we failed it, that lead into give some particular applications for the rural areas, and this is around 2017, 18 or 19. So I will talk about that actually, the same case study for rural area applications using the LoRa technique and IoT as a platform using these devices. Similarly, using the same kind of power amplifier, how actually it leads into the 5G communications technology, which actually can change the whole paradigm of these rural areas if it can be applicable in the rural areas. Of course, these works, it is not that the failure basically lead into some output also, failure the lead into output also, and these devices works actually lead to some 15 PhD works from different university, more than 100 research papers, which actually the anchor was talking about, more than 10 projects, having more than 20 lakhs in each project type. All that actually we got it. But aim is, my aim was to can be able to give some things which actually can help into the rural areas or to the systems levels, basically the solution. But because for these all these actually, we try to do it actually, and we try to get some applications actually, how to use these devices as the sensors basically to monitor the water quality in different rural areas. So that is an applications. I will try to cover sometimes on that. So water is an important natural resource which needs constant quality monitoring for ensuring its safe use. Maybe that if you go from Bhubaneswar to Gunupur, there are a number of ponds where actually the buffalo is bathing, the man is bathing, and we are taking the water from and we are drinking that. How to monitor that actually? What kind of quality of water it is there? Can I able to monitor it? Let's say suppose for that purpose the government has used the gram panchayat and some panchayat officer or some ward members or somebody are directed or they should able to provide the information about the quality of the water which actually the people are drinking. But unfortunately, that could not able to reach into the Rajdhani, the so-called capitals, and hence if we can able to develop a monitoring systems through which actually I can able to measure the quality of the water, maybe that once, twice a day, and I will get the reports automatically sitting at Secretariat at Bhubaneswar or sitting at New Delhi capital. That's basically the aim. Based on that, actually, we try to do this as an applications actually. That's what I'm telling you. Should develop a system to monitor the river water quality based on wireless sensor network, which periodically updates the remote monitoring stations of the water quality data from the river. We have taken it for the river, but which actually can go and which actually we are planning to put it in the ponds and villages also. And for that, actually, as I told you, the sensor device smart voice system solution design should comprise of a sensor signal conditioning interface, which actually leads to my work. Then, as I told you, doing this device work itself actually cannot able to make it a systems, and hence we must collaborate with the others, actually, those who work on the different areas. Because to make a system for this kind of purposes, actually, only the sensor study or only the signal conditioning circuits will not able to help it. And hence, actually, because this need the LoRa wireless communications, or maybe now 5G communication, battery, power supply, processing blocks, and all that, actually. Therefore, we thought that can be able to make a systems. And for that purposes, actually, we thought it, we connected with the different institutes and universities, and we did a collaborative work, actually, to find out it, and if we can able to make a collaborations and can able to make a systems which can be able to use it in the rural areas. Keeping that, actually, we did it. We developed it, and that actually I will be talking it for next 5 to 10 minutes. So this is what actually we tried to did it, and we tested it at the Jamuna River. So how actually it will be? Let's say this is the Jamuna River, and put this is called the buoy. This is called the buoy, where actually you have all the circuitry, and it will touch one of the sensors. Basically, touch to the different sensors will touch to the water, and when the water is flowing, at that time, actually this periodically, depending upon in every 1 hour, the sensors capture the data. There is a processor inside this. It will process it, and it will communicate it through the LoRa communications technology. Either use the LoRa or use the 2G, 3G, or 4G, 5G spectrum, or you can use inside a chip also. But we prefer in this particular case to use it LoRa, because when you put it in the, let's say, Yamuna River at different places, this kind of buoy, then you will not able to get the networking everywhere. Therefore, LoRa connections is used. Similarly, we may not able to get the power supply at each places. Therefore, the solar has been used. And this is what actually the whole thought process that. But you can ask it, why it will be Jamuna. I will answer it that in next few slides, actually. Therefore, the requirement to do this kind of things is develop a sensor system solution to observe data values of water quality. The sensors may be that of, the temperature, diesel, oxygen, pH, specific conductance, turbidity, chlorophyll, psychocyanidin, and all that, actually. Take all that and actually get the concluding remarks whether this water can be drinkable or not. So this, depending upon the periodically you measure it, then LoRa or Wi-Fi, as I told you, or GSM, whatever the communication technology you can use it, Then the data from the smart voice systems will be received at a remote monitoring station to access the water quality conditions. And to do these kind of things, actually, we have done it in two ways. In phase one, actually, what we did is make use of the self-processor broad solutions and sensors, and integrated with the LoRa broadband test. And in phase two, we try to develop the whole everything actually by ourselves. That I will talk with. And for that, actually, as I told you, we discussed with different university, different institutions, and we got a project, actually. Because for doing all these kind of things, actually, we need money, and that money you cannot spend it until and unless you catch to a company, or if you can able to do a prototype through the R&D. Putting a company, actually, nobody will try to put the money, because company, if invest it, then they usually ask for the return immediately. But this kind of prototypes, to make it, actually, government is good one. Therefore, we had asked to the DST, and through that, actually, we had got this project, where actually the partners are IIT Delhi, University of Hyderabad, National Environmental Engineering Research Institute. Then few foreign collaborations were there, like Michigan State University, Stanford, University of California at Riverside, and NJIT. with that of the Nist Barampur actually, where I was there when this work starts it actually. And this is what actually the water quality. So when we get it actually, initially actually I had given the proposal to do it in Chilika, but the government wants that to do it in the Jamuna River. This is because Delhi known places to everybody. What actually the people do it in Delhi, uh, whatever the government try, there are a lot of industry in the Jamuna belt actually. So this industry, they should not allow their, the wastewater to put it in the Jamuna River. They should have their direct places. Therefore, what they do at odd time actually, at night 2 a.m., night 3 a.m., they actually pour this wastewater into the Jamuna River so that the Jamuna River uh, gets polluted. That they want to monitor from which places actually this water is coming, the initiated, and where actually it is going. Therefore, the government wants to put these kind of systems actually at different places in the Jamuna River, and hence actually they asked to do it at the Jamuna River first. But actually, this prototype we could not able to put it in Jamuna River, but we put it in IIT Delhi canal, and we could able to test it actually. So this is what actually it looks in the Jamuna River, and the water, before pollutions and after pollutions actually. It goes it like this actually. Therefore, that actually which trying to put it. Okay. So to do this, basically what I want to say you, to do this actually, protein boil sensors, energy harvesting system, integrated ASIC chips, you need it. Energy harvesting system, you need it. You need the sensors. You need the data analytics, because the data has to be analyzed, and you need the low cost wireless networking sensors integrations, and that is the ASICs basically. And different organizations actually were assigned to do different kind of works, and IIT Delhi was actually assigned to integrate all that and test it. So this whole test actually we actually tested it in a pond at uh, a rural village also. So this is what actually the different. I will not go in details actually, but I told you the summary, how actually it can help it actually, and what actually the different people were assigned to do that work actually. So in this case, particularly the key delivery was sensor for pathogen, this one sensor part, integrated energy harvesting system, field demonstrations using the solar cell, low cost networking and data analysis using your ML, then early warning system for water pollution. So a app, make an app, so that you will get the information in your mobile actually. That is what actually the whole the delivery what actually was given to us, and we had delivered. So first actually when I say that sensors, the COD, BOD, microwave sensors, all that, I will not go in details, but these are the different kind of sensors which actually was developed it to use it in this one. Then because the water flowing, so you have to put the buoy, therefore you need the civil engineer. And this part actually was done by the physical engineers or the chemical engineers actually, including some mechanical engineers also. And when you try to put that, the velocity, you have to measure it, at what velocity actually, whether this buoy which you put it, whether it will go away or not, whether it will float or not. For that actually you need the civil engineers. So this is done by the civil engineer guys. Then, as I told you, the energy harvesting systems you need it. Therefore, the people from the solar cell background you need it. And then finally, this actually was done by the different groups, but finally our work was basically to sensor node integration, ASIC platforms, and sensor networking. These two parts actually was assigned to us. And this is what actually the uh, real platform, which actually used inside the buoy, which actually used inside the buoy. But actually it is there, it is a processor actually. You need a processor where actually you had the sensors, different sensors is there, the water meters is there, water meter sensors, and on-chip PCR-based microwave sensors, antibody sensors, all that actually. Different kind of sensor, different kind of measurement techniques, all that actually has to go through a analog multiplexers. We have we know about the digital multiplexers, but since all the signals are the analog, therefore you need an analog multiplexers that has to go through ADC, analog to digital converter, and that actually go to that will be filtered, testable, memory, and that actually will connect with the processors actually. Processors, maybe that a small microcontroller, or maybe that uh, a big processor, depending upon that. And for all these cases, actually, you have to do the power management. You have to do the power management. So this power management is important because this ADC, when you put it inside that, actually, it should give a stable power, stable power. And then again, once you get it, actually, you again transfer it in from the digital to analog and send it to the antenna. Send it to the antenna, through the antenna, send it and communicate it to your receiver end. Receiver end, the server will receive it. Then the people from the data analytics uh, background basically will capture all that data, and they will analyze it and will provide you the concluding remarks that whether this water can be drinkable or not. All this process actually, uh, once you fished it, everything and did it, all these will take around 5 to 10 minutes only. Okay, so this is what actually the whole thing was done it. So this is what actually the boy developed, keeping all that in point actually. This is what actually the boy developed. The proper boy and all that uh, is replicated initially by the prototype, by ourselves, where actually we had used the NIST different faculty members and students. The mechanical engineers had done this boy. The electrical guys had done the solar cells. We had done these ASICs devices. It has been put on it. A motor was connected with a remote control. The computer science guys were used it to develop it the app, and they had developed the app. And this actually has put on it in the a pond near a village called the Golden Thora, and was tested it directly by us also. Okay, so basic of the cells, as I told you, all that actually we had purchased it and had put on it here, and we had tested it actually, and that water quality actually has measured it. These are the sensors which actually fabricated that we had purchased, and we had actually tested this one, and we had seen the temperature, then the pH, the DO, the conductivity, ORP, all that actually we had tested it. And mobile app was developed it. So this through this mobile actually, if you pushed, we call it as the NIST Wacom mobile app. Using that actually, we are able to read this actually. Time to time also you can leave it, and for that actually, let's say temperature, DO, sitting anywhere actually, you can able to measure it. Therefore, these applications basically, if we can able to make it generalized, and this prototype, if it can be converted into a mass production, can be used it in different villages, ponds, and we can able to uh, get the information on water quality. And for that actually, we have given the proposal to the government of Odisha also, that as a prototype actually, can you allow us to give 20 pieces of this kind of sensors, which actually this type of boy, which actually each of these will cost around 1 lakh. If you go to the proto, but when we go for the mass productions, actually the cost will comes to be around 10 to 20,000 only. The 20,000 around only the cost will be there, which is actually affordable. You may ask a question, that so much costly one, why will you use it? So 10 to 20,000 only, the government is spending so much money, so they can do it. This is what actually one of our aim, to take it into the rural area, put it, because the water, if we don't get it, proper one, then all kind of disease, everything is again cumulative one actually. So this is again, I will not touch all these IoT architecture and all that. We have measured the COD, BOD. For that, actually, we have developed the MI model, the ML model, and all that we have developed it, and we have measured all that actually, all that in one way, and that results and all that actually has been verified and published it also at different journals. Simultaneously, what actually we are trying to do it, the sensors which actually of the cell we purchased it actually, can we able to make it our own actually? Can we able to design, fabricate, characterize everything our own, so that it can be used it, and hence the cost what actually I'm telling it, it will cost around 20,000. This actually will lead into a cost of around 5,000 only, 5,000 to 10,000 only in the boy. And for that actually we have started doing the work, and this So anyway, this ADC and all that whole systems where actually, as I told you, there is a power management, there is a microcontroller or processor, there is the integrated solutions, there is a power management, and there is the analog multiplexers, amplifier, and analog to digital converter. This is what actually the whole structure is. So this one, if I able to reduce it, and if I take only this part, integrated solutions part, if I take it, uh, pressure sensor, temperature, humidity, let's say, uh, provide it with the analog multiplexers, AD converter. This converter actually, once you convert it into the digital signal, you need a digital filter, which actually uh, will remove all the unnecessary spurious. Then low power microcontroller, which actually will process it to give the data, and this data may go to the IO. Whereas if I want to save that, I can have a memory. I can have a memory. Therefore, at the first stage, actually, what we have tried to do it. Uh, oh, I have not. I have removed that actually. Sorry. So in the first step, actually, we have tried to design this one by ourselves. Power management, digital filter, and digital register memory. So this analog multiplexers, we did it, and this is what actually the whole IC design it actually. Whole IC design, where actually you have a voltage regulator, filter, memory, and this is one, which actually able to control the whole IC. And we gave this as the name the Mercury actually, where the voltage regulator, memory, and filter is there. And that we create it using the, so I will not go in detail. So one part I can cover it, and which actually I can generate it. So in this voltage power management, there is a circuit called as the voltage band gap reference, which actually those who are doing it, the VLSI course in 8th semester, they must have read about this BGR analog IC, of course. And they are actually, and this BGR, we design it, then all kind of analysis like DC, AC, small signal, stability, transient, all kind of analysis has been done it, and these are all the results actually. And finally, this is what actually the layout of the IC designs, and that we have done it using the cadence tools. Then the voltage regulator, the final one actually. Similarly, I will go to this one, the voltage regulator, and then the LDO, low drop output voltage, that actually has been designed it also using error amplifier and all that. I will not be going to that in details actually. And finally, this is what actually the layout we had got it for the voltage regulator. And we tested it. Then, as I told you, the filter. This actually is the analog IC. This one, what actually I showed you, you have to do it as the analog IC, and analog knowledge is necessary. Whereas the filter and memory, you need the digital knowledge. So this filter actually we did it using the, again, filter, design it using the MATLAB initially, which actually we took it into the GIET, and from there actually we implemented the physical design, and we took it back again to the cadence tools actually. Cadence tool. So this is what actually the filter, basic filter actually, which you might have read it, the Chebyshev filter, the Bessel's filter, that kind of things only actually it is only the digital. So first he did it in the MATLAB, and once he did it in the MATLAB, after that actually, and once we say that this is the final one, we took it into this MATLAB into the physical design. First we did it using the GIET, and after that actually we took that RTL code into the cadence tool, and we used the NCC's encounter and encounter for the physical design, for the synthesis, NCC's for the physical verifications, and then the finally physical design using the ESURA. And that actually, I will not go again in details. Using that actually, these are all the design techniques which has been used it. And finally, I will go this results match and all that. Then we did the memory also. I will not go in details. Then finally, as you say, you need a memory filter and this power management. That things actually we did finally, and this is what actually the IC we have obtained it. The inside of that IC, which actually fabricated using the iMac, and this, if you look it on the inside of that IC, this is what actually this IC is fabricated. Then this IC has to be tested it. So post silicon, basically the test has to be done it. So a PCB design it and PCB design using that, and actually it is tested. It is tested, as I said that, and this IC basically we are calling it the Mercury test IC, and this is tested for the using these are the equipments which has been used it. Again, I will not go into the details of that, and these are the few equipments and test results. We say that we got a proper results. We got the proper results on that. This basically what I want to say, again, and we could able to make an IC, which actually the long way to go is to put it in the water quality, but this is one of our aim actually. I'm telling it, so if anyone is interested, they can be part of this actually. This is a government of India declared project where actually anyone can also join it, but of course they have to contribute it. Of course they have to contribute it. So doing that actually we could able to do the IC, and we could able to make it, as an application, so we can able to put it in water quality monitoring systems, which actually we are using it now by purchasing that. So with this sustainable energy rural areas, what actually the government is saying, we can use these kind of things basically and contribute our technical knowledge as well as our research area, instead of just confining to publish the papers and research. Instead of that, actually these type of some things which you do it, which actually will help directly to the manpower menu and can help into the rural areas also. Of course, to do this, all this work actually, the different companies will help us, different company, different organizations et al. So we must thanks to them. So when we did this LoRa actually, LoRa is not actually, is standard, is not a standard techniques actually, standard spec actually, standard spec. And that's, therefore, the LoRa technology could not able to popularize actually, could not able to popularize. And in the meantime, the 5G technology came. Therefore, we jump actually, instead of using LoRa technology, can we do it using the 5G communications technology? Therefore, jump to 5G area, and as it says, this is another one applications which actually can be helpful to the rural areas. Either use it in the sensors in this buoy instead of LoRa 5G, or use it as a base stations which actually replace all the GSM. And if we can able to get this 5G communication actually in rural villages, then dramatically actually, pragmatically, all these actually the rural areas concept will be changed. Because in 5G cases, the data transfer will be within 1 to 2 Gbps per second. Therefore, sitting at home, actually, the rural people also can able to do everything actually, which now is becoming a impossible task types. Therefore, we jump to this 5G communications technology, and we are working. And in any 5G communications technology, as the last talk it said that it will go through the fiber to the base stations. From the fiber, actually, you have to connect to the radio unit. You have to connect it to the radio unit, and radio unit actually transfer the data. And for that radio unit, basically, what is there inside that? Inside that, actually, there is a power management again, the controller, the battery, no doubt will be there, mic, speaker, SIM cards, all that will be there, and a baseband and RAM will be there. That is the digital part. This digital part actually will convert it into analog through a RF transceiver, and that analog actually convert it into, will go into the analog front end actually, analog front end, where actually our research work what we had done it on the HEMT kind of power amplifier are using it in these particular cases, and that actually helping us to be part of this whole systems actually, and that actually will lead into the antenna, and the data will be transferred. This whole things basically system is called as the radio unit. So those who actually, if you have marked it, in the tower and all that, if you see there is an antenna, there is an antenna, big antenna, you might have seen it, the lengthwise, maybe that, 1 meter type. And with that, actually, you just mark it in the tower, there is a small box type. That box is called as the radio unit actually. That box is called as the radio unit. And that antenna which you use it called as the sector antenna. inside that actually, as said that, this one basically is this one, the digital board, then the transceiver, then the RF front end, then the antenna. Those who actually interested, can work on the antenna, can work on this filter, then can work on this RF front end, can work on this transceiver, or can work on the digital baseband actually. Digital baseband. These are few examples where actually I'm involved and have done it directly, which actually has gone to the field, for the testing purposes. And this basically, my aim is, can we able to use this kind of technology in rural areas to solve the different kind of issues. That's what actually is my current work and current thought process basically. Can we able to take these 5G communications to the villages? Yeah, that's only, I talk it in general. I don't want to go into the deep. Those who are interested actually to go into the deep can connect me through my mail. And my acknowledgement basically to the different people, the different companies, and mostly, the, as I said that, this 5G things basically I am doing it through one company called the PPDN Technology, which is a ODM company, and PLI scheme through that actually, if you have read the newspaper, the government has given 10 companies as the PLI company. PLI means Professional Link Incentives. VVDN is one of them actually. Through them actually, I am trying to pull this 5G communications technology to rural India. This is what actually my talk is, and if any questions is there, you can ask it. And if anyone is interested to collaborate technically and all that actually, you can write a mail to me on this akponda612@hotmail.com. Thank you. Yeah, I think I finished at right time. Hello? Hello? Am I there or no?
Yes, sir. Yes, sir.
Yeah, so that's my talk actually, the general. And if anyone has any questions or
Audience, do you have any questions? Audience, do you have any questions?
Good morning, sir.
yeah, no questions actually. Very bad actually. Then my talk was not good.
No, sir,
No,
we are
no,
having
sir.
some
I have a
questions, sir.
question, sir.
Okay, sure then.
Okay, sir. Good morning, first of all. And my question is that who is technology we should use for better communicate with wireless sensors, sir, and why?
What is the question?
Who is technology? Who is technology we should use for better communication with wireless sensors, sir, and why? Like you mentioned, LoRa.
That LoRa technology, it is a very means private technology actually. It is a private technology, and hence is not a generalized one actually. For that actually, there is no particular specifications. Let's say suppose if I do it a 4G technology or 5G actually, then there are the International Radio Union who actually uh, International Radio Union who actually specify the specifications, and it is called as the 3GPP standards. Therefore, in that case, actually, wherever you go, the standard is same, and you have to fulfill the standard. Therefore, suppose something goes wrong, actually, then the other can able to help you. Whereas, LoRa is a very private techniques, actually. Of course, it has its own advantage, but cost-wise, if you look at, the LoRa technology, because popularly it will be not used, very few people will be used, so cost-wise that will be very high. If anyone is interested to have its own private technique type, then LoRa is good, no doubt on that.
Okay, sir. Thank you.
Hello, sir.
Yeah.
Sir, my name is Pritam Jana, and sir, I have one question, sir.
Yeah, sure.
Sir, how sir gun diode is operating in both direction means sir how it is reversible, sir?
Gondor is simple device, man. Simple it is a semiconductor, linear semiconductor, like a resistor type. Therefore, it can work in the both device, both sides. Negative resistance, what if you are asking it, I think that is your question. Negative resistance means if you look at, gallium arsenides or gallium nitride actually, all third fifth compound semiconductors, what it happened it with increase in voltage actually the current decreases after a certain field value. After a certain field value. So if you look the velocity field characteristics, unlike that of the silicon, the velocity increases with respect to electric field and remains constant at some places. Whereas, in these materials, velocity increases initially, then actually it decreases, and after that actually it remains constant. So the region where actually the velocity decreases, that region you can use it as a negative resistance region. Negative region because with increase in V, current is decreasing, and hence it generates power. It's a power consumption is V into I, positive value. Whereas in this case, the V into I is negative. Therefore, in this case, power is generating,
Okay,
and
sir.
hence it used it for the very popularly. It used it actually.
Yes, sir. Yes. Thank you. Sir.
Sir, namaskar. Sir, Tushar here, sir.
Yeah, Tushar. Yeah, good afternoon.
Good afternoon, sir. Sir, we'll start the validatory section in the same link. We are just waiting for one more guest to join. So after 5 minutes, we'll start. You can just refresh for 5 minutes or so. We'll start the validatory session in the same link, sir.
Sure. Then 5 minutes, if someone can ask some questions, it would have been
Yeah,
good.
I'm handing over the mic to the students again. If they have any questions, they will ask. And in
Yes.
the same link, we'll continue. Thank you, sir.
Yeah, thanks.
Thank you, sir.
Thanks.
Thank you for sharing your profound knowledge on different kinds of diodes, MOSFETs, and different VLC circuits, and how it can be used for development of communication system. Your session was full of Jill and profound knowledge. Thank you.
Thanks. Thanks. Okay, then I will join it after 5 minutes, right? Yeah, Dr. Surajit is there, right? So,
Namaste, sir.
yeah.
We'll,
No.
we'll continue, sir,
Hmm.
within 2 to 3 minutes. Let all the people will join. We'll continue.
Okay, so I'm in the link, huh?
Hi, sir.
Yeah, thanks.
Hello.
Yes, sir. Sir, good afternoon, sir.
Good afternoon.
Sir, we are just waiting for one more speaker and we'll be starting in 2 minutes.
Okay.
Sir, good afternoon, sir.
Good afternoon.
Sir, I think Dhananjay sir also joined.
Yes.
Dhananjay sir, good morning. Good afternoon.
Good afternoon. Good afternoon, sir. Pradhan sir.
Thank you for joining with us, sir. Thank you, sir. Let me check. Patnaik sir, good afternoon.
Good afternoon.
No, BN Patnaik sir.
Ah.
Sir, can we start now?
No, just wait. Sir, good afternoon, sir. We'll start the
Namaskar. Anyway, I am happy with my teacher, sir, and my teacher in Burla, sir was. And Subrajit, all are Konda, sir. We know well since a long.
Ajit Panda, sir.
Sorry.
Sorry.
Yeah, good to see. It was mute actually. So, good afternoon, everybody. Good afternoon.
We are with a family, sir.
Yeah,
Gurus, everybody is here.
that's nice actually. That's nice at least.
So can you start, Tushar sir?
Yes, sir. Yes, sir. We can start now.
Let's check with Padmini madam. Sukant sir will join or not because he has some meeting.
Called. He is busy actually in some meeting.
Okay. Let we'll start because we have puja in our college. I think our authority will not join. Okay, we'll conclude the conference.
Okay, sir. We'll start then.
Yes, we'll start.
Now for the continuation of validatory session, I would like to invite Mrs. Asima Sindhu Mahanti.
Hello.
Yeah, it is audible.
Yes, sir. You're audible. Yes, sir. Audible. Well, good afternoon to one and all. Good afternoon to one and. Well, good afternoon to one and all. Finally, we arrived at the valedictory ceremony of this international conference on smart and sustainable technologies. It had been since 3 days that we are here attending the invited talks as well as the research topics we are hearing. And really, I hope that all the participants, you gain a lot of knowledge regarding smart and sustainable technologies. It had been a way, it had been a path which showed recent technologies, the ideas upon recent technologies on smart and sustainable technologies. Well, in continuation with the valedictory session, first of all, I would again like to welcome all the dignitaries as well as the participants. And now for me, it's the time to invite such a personality who is the program chair as well as the convener of International Conference on Smart and Sustainable Technologies 2021 GIET University, as well as that person is the navigator of electronics engineering who wholeheartedly dedicated his leadership for organizing this international conference. Please welcome Dr. Subhrajit Pradhan. Sir, please kindly address the noble gathering.
Thank you. A very good afternoon to one and all present over here. Respected Dr. P. Dhananjay sir, Vice Chancellor, Peter Institute of Higher Education Research, Chennai. Dr. Ajit Panda sir, PDF USA IEEE Distinguished Lecturer, Bhubaneswar. Dr. B.N. Patnaik sir, Assistant Professor, Department of AC, IIIT, Bhubaneswar. Dr. Sikant Patnaik sir, General Chair, ICSST, Professor, SOA University, Bhubaneswar. Dean Academics, Register, Vice Chancellor of GIET University, my faculty, students, once again, very good afternoon to all. On behalf of department, I'd like to thank each and every person, those who have contributed for our conference. Let me speak something about our conference. With guidance of our Sikant Patnaik sir, we have started and we have planned to organize this conference. The objective of conference to continue the series in every year with lot of discussion with faculty members as well as the mentors as well as the outside experts. We have decided to finalize or we have finalized the conference topic as a common topic so that we can continue for next 10 years. Thank you, Sikant sir, for giving us the guidance till now. He is guiding us to make this conference a grand success. I like to request some kind of cooperation in future years. With that, we received nearly 111 conference papers for our conference, and it is reviewed, and nearly 40 papers are selected, and it will be published in our IEEE Splinger series. And as already I declared that we'll continue this series and we'll organize the same conference, the second edition of ICSST 2022 in the month of December, that is 15, 16, 17, 2022. And I'd like to thank all the invited speakers like Dr. Priyadasi Nanda, Professor, Department of Electronics and Computer Science Engineering, University of Technology, Sydney, Australia. I'd like to thank Dr. P. Dhananjaya, Professor, Department of Electronic Communications, our Vice Chancellor, Dr. Hari Krishna Mandram, Professor, Digital Brand Ambassador and Chairman of Vision Digital India, Vice Chancellor, Global Digital University, USA. I'd like to thank Dr. Chandan B. Samantrai, Professor, College of Engineering and Technology, Virginia University, USA. Dr. Romania Madam, Dr. Roman Sar, Dr. Arunanshu Mahapatra, Dr. Ratnakar Das, Dr. Pradit Kumar Vishwal, Dr. Subhendu Roop, Dr. Murtinjay Panda, Dr. Santosh Kumar Das, Dr. Vasudev Behra, Dr. Dhruvacharan Panda, Dr. Sukant Tripathi, Dr. Vijayanand Patnaik, and Dr. Ajit Kumar Panda was given the talk from last 2 to 3 days, and it is definitely helped our students, research scholar, and all the faculty members. And also I'd like to thank all the session chairs. We have gone for 4 tracks, and in which track number 1 is IoT, Big Data and Cloud Computing. Track number 2 is Smart Communication and Smart Technology for Smart Living. Track number 3 is Machine Learning Techniques and its Applications. Track number 4 is Smart Energy Systems. And we have chosen, we have gone for 4 track, but it is nearly 7 sessions. So we are just going to give the best paper award for the 7 sessions after the end of this validity function. Once again, I'd like to thank all the participants, authors, reviewers, and invited talk professors and like your session chairs, research scholars for contributing for our conference. And not for the least, I'd like to thank my all faculty members, those who have supported me for organizing this conference. I'd like to thank all the non-teaching staffs. And at the last, I'd like to thank all the students, those who have did lot of works, because initially we thought of to organize this in offline mode. Suddenly we have changed it to online mode, but this we have converted into blended mode, that is online plus offline with a lot of efforts. I'd like to thank everybody for supporting to make this conference a grand success. Thank you.
Well, thank you so much, sir. First of all, I'm also thankful to you, sir, because it's really, actually, I can say, you were enthusiastic to take a step regarding organizing this conference, and we can all see the successful accomplishment of this conference, and we really wish, sir, that the future conference in the year 2022, we really hope that it should be held in offline mode, because during this pandemic situation, as we all can see, we have organized this conference in online mode, and quite it is successful. So we really hope that this conference series will continue on like this, but in offline mode. Thank you, sir, so much for showing your enthusiasm for organizing this international conference, due to which we staff members were also motivated to keenly support you. Thank you so much, sir.
Thank you, ma'am.
Next, moving forward, ladies and gentlemen, now I'd like to invite such a personality among us who is the General Chair, ICSST 2021, and Professor at SOA University, Bhubaneswar, Dr. Shrikant Patnaik, who not only motivated regarding this conference, but he was a person behind this conference who took the initiative and gave the idea. He showed us the path, and under the guidance of him, we organized this conference, and I hope we successfully accomplished this conference. So without any further delay, I'd like to invite Dr. Shrikant Patnaik to address our noble gathering.
Good afternoon, all of you. Since last 3 days, the teachers, student, as well as the audiences, they must have learned a lot out of this discussion and panel session. In fact, nearly 6 months before, when there was a brainstorming session in the Department of Electronics and Communication Engineering in GIET, the teachers were discussing in which area they should do. So maybe it is a microwave, maybe solid state, maybe communication, and there are proposal of 5G communication. So I suggest that keep a title which will be attractive, which will remain for at least say 5 to 10 years, and it must be specific to your area. So not only that you will say have a conference on machine learning, and your say surrounding will not match with the topic. So therefore we finally conclude, let be say smart and sustainable technology for tribal and rural development. And you must have received the feedback from international gathering, whoever has participated in this. And definitely this is the suitable title we have chosen. There is no doubt about it. Secondly, how to encash it in future. There are ways and means. The student, they must have participated and listened to the speakers. Now it is time for all the teachers to alert small projects on, say, the IoT devices and machine learning for the livelihood of your surrounding, say in agriculture, in say household, it's a small project. I remember when we were BTech student, there was a book was coming, Electronics for You, and there are small projects were coming, and we used to do that. Now it is available in internet. Many projects are coming, mini projects are coming, and you should do that, giving a slight change to your surrounding, to the tribal people, to the rural villagers, and you will see it will catch the attention of the others, and it will benefited you in your job profile, to getting a job in your interview, as well as it will give say value addition to the this conference as well as to your university. Similarly, the teachers also, they can think about out of the project how they can encash for their PhD, and to bring out some article in the say reputed say either magazines or journals. So there are outlets where the student can also publish their projects. It is not necessarily that you are going for a reputed journal waiting for 3 years time, because the enthusiasm of the student will fade away or die down after just passing out from the campus. They are going out of the campus, they will forget everything. So before they went out of the campus in the month of April or May, you have to plan to give a save to the project, and they should publish somewhere. There are numerous say verticals are available. When I was visiting GIET campus, I had given some of the links where the student can participate and student can publish their projects. And also the teaching community, as well as whoever are the mentor of your university, you can plan to bring out a yearly book or the annual book on the development of the tribal and say rural area, using only the technology, not necessarily the electronics, but say mechanical, civil, whatever, whatsoever may be. So that will give you a mileage and a reputation of the university. And everyone knows the if your administration is attending this session, everyone knows unless you have a ranking in NRIF, you are nowhere. So your reputation, your NRF ranking, or your presence in the net will speak about your university. No need to speak around, or no need to circulate the information brochure or the leaflet. So the teaching community should work in that direction, and we have received a good platform, ICSST. It will continue year after year, and definitely I can extend my help to this platform. Thank you.
Thank you, sir. Thank you so much for your supportive as well as the words which can guide our students as well as the mentors associated with them. We will definitely put emphasis upon the points which you told, which you suggested now, like the students' projects. The projects should be handled by the students under the under the guidance of some mentors. Along with that, the mentors will be also responsible to plan for an annual book where the students' projects, their capabilities will be published, not only in the annual book but also in the magazines. We should also try to do something, to do some projects for tribal as well as rural people. As you all know that Gunupur is an area which is consisting of vast number of tribal as well as primitive people. So definitely, sir, your words, your suggestive words will be helpful for us to continue with this conference series. Thank you so much, sir, for your guidance and for your support. Thank you so much. Well, audience, moving forward, Now we have one personality, one academician, as well as one researcher among us, who is presently the assistant professor in the Department of EC, Triple IT Bhubaneswar, Odisha, Dr. Vijayananda Patnaik, who is one of the scholarly sculpture. And now, without any further delay, I'd like to request Dr. Patnaik to address our noble gathering. Sir, please. Dr. Patnaik?
Yes, good afternoon. Thank you, madam. I think it is audible.
Yes, sir, you're audible.
Thank you. Good afternoon to all of you. And since last 3 days, I think it is completely a hat trick.
Excuse me, sir. Sorry for the interruption, but
Yes,
your
madam.
camera is not on. If you can kindly, can you please switch on your camera?
No, no, I have connected through two devices. Camera is on. You can
Okay,
check
okay,
it.
okay. Okay, sir. Okay, no problem. Kindly
Right, right.
continue,
Sure.
sir.
Sure, sure, madam. So since last 3 days, I think everybody is completely busy, and the students and the scholars, faculties, organizers, and what I have seen, it is a completely well organized, as well as very nice conference. And in the present context, no doubt everybody is trying to develop the technology, trying to do something for this society, and all those. Perhaps they are forgetting the impact of environment and what the suggestions from Srikant sir as well as all the organizers, what I have seen, the sustainable technology which will work for another maybe 1 decade or 2 decade. So that is also to be emphasized. So that is what you have done, that green technology, sustainable as well as smart. So which if you taking into consideration of all these things and especially the environmental effects, then definitely, no doubt, the technology what we are developing will be useful for the society, for this large public, maybe for the government also. So that is what I think the theme or the name of the conference is widely accepted for another 1 or 2 decades. And we are getting, and the invited lectures were around 16 invited lectures. What I have seen, which is a great one, and different aspect, different fields. All these invited lectures, as well as the professors, researchers, industry people, has touched in different areas, which I think it is a very good thing. And I think students will have an overall idea. No doubt they may not have in-depth knowledge, but overall idea in different fields and different aspects, what the present trend, present technology is going on, what Srikant sir has also suggested to carry forward, what to do in future and what we will do is an important thing. So that is why I don't think so that with the conference, the technologies or the discussion should not be ended. It should continue further. What we are planning the series for the next year, next to next year, it will continue. It is a very good thing. As well as I can also tell some of the areas what you people has listened, around 16 talks, and in between, if possible, 1 or 2 days of workshops also you can arrange, so that you will have a hands-on practice in live, in reality. You can see how the people are playing with technology, working with the technology, how it is useful for the society. That you can also the UG, PG as well as PhD scholars. The PhD scholars can publish papers. The UG and PG students can go for very good projects of the latest technology, as well as faculties will also be benefited in terms of writing projects to different organizations and different things. So that is why what I hope all these things will continue in future. And no doubt I was also working in GIET for 6 years, where the academics as well the research is a very but serious things they are taking into consideration very dynamically. So that is why I think the university will definitely continue the same. As well as at the end, I can tell that I would like to thank all the organizers, the general chair, as well as the coordinators. Different each and every session they have arranged different coordinators. They are coordinating very well. The faculties, the students, as well as all the audience. So that is why I would like to thank, as well as I would like to thank the management also to think all these things in a positive direction. And at the end, I can tell that in future, let us have a workshop and conference like this in the series. And I can tell that very thanks for giving me this opportunity and to make it. And I can tell it is a grand success also. Thank you. Thank you all.
Well, thank you, sir. As you all know, that B.N. Patnaik, sir, was one of the GIETians. He was here in this GIET university, but presently he is in IIIT Bhubaneswar. And every time, since a long time, since I know, sir had been one source of motivation for all of us. As per the suggestion, sir, definitely one workshop. We will definitely try to organize one workshop for this conference series. Definitely, we will try to organize one workshop as per your suggestion, and really your supportive words regarding the justification of the name of this conference is highly appreciable. We really appreciate for your justified words. And as per your saying, technologies which are used in this research are well justified as per the name. Thank you so much, sir, for your appreciation and motivation. Thank you.
Thank you all.
Well, audience, now due to some work, due to some schedule, Professor Dr. Gautam Ghosh was not there. Presently, he joined. So I'd like to invite Professor Dr. Gautam Ghosh, Vice Chancellor, GIT University, Gunupur, to address our audience with his words of wisdom. Sir, please.
ଆଜ୍ଞା କଣ କହିଲା
Sir, Vijay, sir. Dr. Ghosh. Gautam, sir. Okay, due to some technical issues, presently Ghosh sir is unable to join. Now moving on to among us again, one academician as well as I can say, I must add the term researcher. Dr. Ajit Kumar Panda, he is present among us, who is the Senior Director, Research and Development, VVD and Technologies, Bhubaneswar. I'd like to request Dr. Panda to address our noble audience with his words of wisdom. Sir, please. Ajit,
Sir, unmute your mic. Unmute.
Sir, sorry for the interruption.
Sorry. Yeah, so good afternoon. Again, Asim, as usual, thanks for introducing. So, really, I must thanks and congratulate Dr. Srikanth Patnaik first for his, for last 20 years, which I know it actually, that always he preferred to have this kind of conference. And people like me, are coming after 3 calls and delivering a lecture that is also half-heartedly, whether I will come, give it or not, type of things. Whereas, he has taken the keen interest and was doing it in Bhubaneswar only. So, but now he has moved to our rural areas. For that, actually, we must thank him, and we should give a big hand to Dr. Srikanth Patnaik for his contributions, basically how to improve the environmental of education systems through conference, research, and work, actually. So thank you, Dr. Srikanth Patnaik. Thanks, actually.
Thank you.
Yeah. Dr. Surajit, as usual, he must have to do it, and Srikanth has drive it. So Subrajit and all his colleagues, basically, I have seen them also. They are very enthusiastic, and that is why actually when they call me, actually, I do not have any other options, yet I join it. Though I see, the watch, how much time is actually spending and all that with busy schedules also. When Surajit call, I do say that I have promised them, including their president, Dr. Satya Panda, that whenever you will ask me to contribute to that, I will definitely will be available. leaving all the works. This is because the Gunupur is a place where actually this is the only one place in Odisha where actually the rural areas and the education systems is also at a is maintaining actually is maintaining nice campus, nice people, nice works, nice students. They are doing it. Therefore, we must congratulate Subrajit, the management, and everybody for contributing to the rural. And all the speakers, definitely, I could not able to listen to everybody, but good that listen to Dr. Bijay Patnaik last few words on the fiber communications and how actually the fiber is communicated to all the places in rural areas. And only one line I will tell it, I will say that the any conference or any works that we do it actually, output do not come, the output may come, or you can say that success or something. But as per my view, the outcome actually comes after 5 years, 10 years actually. And those who attended this conference actually, the students or any other also, tomorrow you may be in a big position, someone of you may be an IS, someone you may be, a technocrats and all that you may be. But if you keep it in mind that, yes, this conference I had attended for the sustainable and smart technology for the rural areas, and if you can contribute actually, some things to the rural areas, then actually we will say that outcome of this conference is successful. And at that time, actually, Dr. Srikanth and Dr. Subrajit will feel proud if they know that, in this conference, these students had attended and he is now ready for the contributions in the rural area. That is what actually my view for the students is. And as a teachers, we are proud, we feel proud when this type of things comes actually. So wish you all the best, the students actually. And let us see when actually people like Dr. Surajit, Dr. Srikanth, me, or other faculty members will be proud of you. And we'll see when actually you will contribute directly or indirectly on the development of the rural areas on smart technology and sustainability technology. Thank you. Thank you.
Thank you, sir. Thank you, sir, for a valuable award. Our president, sir, is already given a task to us to adopt a village, and we have to make it a smart village, and that is our target. And our chairman AICT has also given a target to our college that we should develop a smart village within 3 to 4 months. For that, we will start our project and we'll go for a thorough visit to our village and what is the requirement. According to requirement, we'll start our implementing the things. Okay, in that process, I'll take your help, and how we'll adopt the village and how we'll make it smart by using different IoT device and different technology that will take, and I'll discuss with you. Definitely will implement as suggested by Patnaik sir also, BN Patnaik sir. We'll go for workshop, and next conference we'll do workshop in lively in the one village, and definitely it will be a fruitful conference. Practically will implement, sir. That process has been started, sir.
Thanks.
Thank you.
Supplementing to Dr. Subrajit,
thank you.
I must tell that this is the beginning, and if you will apply for AICT project, this will help you. This proceeding of this conference will help you to get the project from AICT.
Thank you, sir. Definitely, sir. Definitely.
Well, thank you so much, Panda sir, for your valuable suggestions regarding the outcomes of the conference. And the outcomes will be definitely from the student side as well as from their associated mentors. Thank you so much for your motivational words, your support, and also out of your busy schedule, because we all know that you are very busy, and out of your busy schedule, you spare some time among us, delivering some of your ideas regarding sustainable and smart technologies. Thank you so much, sir, for all your support and motivational words as well as suggestions. Thank you. Well, audience, now I'd like to invite Honorable Vice Chancellor, Professor Dr. Gautam Ghosh from GIET University, Gunupur, to address our noble gathering with his words of wisdom. So please.
Just a second. I'm trying to.
Yes, sir. Yes, sir.
Okay.
Sure.
Okay. First of all, very good morning. It's now good afternoon actually. So, meeting in this valedictory ceremony, I was hearing some of these experts and Dr. Panda and has been mentioning quite a few important points for our students who are going to be the leader in future. Uh, first of all, last 2 days I was not though attending this, but as I get to know from my colleagues, this has been very successful and a lot of new thoughts and ideas were discussed. And I'm sure the students, our students, of course, the faculties as well, but the students must have enjoyed it very well from meeting such senior and the galaxy of experts that these 2 days who have deliberated. Otherwise, it would have been very difficult for them to learning so much thing in such a small time and from those these stalwarts in one platform. So that's itself, it's a very big and credit goes to the department for organizing this very nicely, comprehensively, and then with this actually I would like to give my sincere thanks to all these experts and senior colleagues and the leaders who, despite their all your busy schedule and activities, meetings, have considered valuable time for these institutions and academic place, and which is the best part. If anybody, even he is not a faculty, but he is an expert in another institutions, giving any time for academic institutions is, in fact, for some time in life is very useful and is in a very noble kind of a thought. So I would even request some of you, whenever you have time, if you can interact with our students, we would be grateful to all of you. So thank you very much. Thank you all of you. Thanks our department team who has very well organized these things very in a short time. But we wish this, as some of you suggested, in a series that we will have a in a physical mode. We all tired with this what you call online mode of things, which is though good useful, but we would look forward sometime to have it in a real conference mode, physical mode. In hope we come towards a better time. And thank you very much. Thank you all for this 2 days conference in your time. Thank you.
Thank you, sir. Thank you so much for your appreciable words towards our students, faculty members, as well as the organizers of this conference. Thank you so much. Well, research is always creating new knowledge. Today among us is present such a personality who created new knowledge and still is creating new knowledge. Dr. P. Dhananjayan, Vice Chancellor, St. Peter Institute of Higher Education and Research, Chennai. Without wasting any further second, I would like to request Dr. P. Dhananjayan to address a noble gathering with his words of wisdom. So please. Dhananjayan, sir. Dear audience, due to some technical glitches, you have. Please wait for some time. Sir will soon join with us. Well, audience, now it's the time for me to request Dr. Priyadarshan Parida, the organizing chair and coordinator of International Conference on Smart and Sustainable Technologies 2021 GIT University Gunupur, to share his words, his experience regarding this conference with our noble gathering. So please.
Thank you, Chair Madam. I hope I am audible.
Yes, sir, you're audible.
Okay. So, thank you all for organizing this particular thing, and this particular thing we have started preparing, I think, with Srikan Patnaik sir since I think February 2020, and this entire event was started from that day, and we have received approximately 110 numbers of papers, out of which I think we have scrutinized 40 papers for this entire conference. So that indicates that the level and the quality of the papers that we are maintaining in this particular conference, and with support of all the staffs of our department from GIT and the other reviewers who take the responsibility for reviewing task of this particular manuscript, because each manuscript was reviewed by 3 to 4 reviewers, and after that they are scrutinized and they are finalized for this particular conference. But all of us are seeing the presentation right now. So this conference was a grand success, although this time we have not received the scopus from the Springers scopus proceedings. I hope we'll get that thing from our next series, next 2022 ICSST. And it is all of due to our support of Subhrajit sir and Srikan Patnaik sir. So I'd like to thank them all for this entire thing and for their support. And I hope this conference success will continue for 2022 also in the same way what we have done this year. So thank you.
Thank you, sir. Thank you so much for sharing your experience regarding this conference. And it is indeed absolutely right that you are also the backbone of this conference, and you are also one of the reasons for the successful accomplishment of this conference, and hope to organize the series of this conference in offline mode in the next 2022 December. Thank you so much, sir. Well, audience, as you all know, research is related to creating of knowledge. Today among us is present such